Okay, let's get started. So this is Veysel Kocaman, CTO of Johnson Labs. So this is the first day of our certification trainings. So I'm going to start with the introduction to Johnson Labs ecosystem, product portfolio, and our latest medical language models. And then I will do some high-level overview of what we are trying to achieve here. And then what you are going to learn during the certification trainings. It's a 4-day session, which I'm going to share the agenda as well. Let's get started. So this is the agenda. We have 4 days, as I said. So this is the first day. Today we are going to cover. So we have a large team here at Johnson Labs, right? So everyone is responsible for their own session. So we will have like 16 different sessions during the 4 days. And then I will kick off this training with the first session, which is an intro to Johnson Labs ecosystem. And then after me, we will cover how to deploy LLMs as the private endpoints. And then we will end the day with the Gen AI Lab, which is our application for annotation projects and then managing the taxonomies, etc. So we will have a large session just for Gen AI Lab. And then tomorrow we will cover healthcare specific language models. This is a hybrid session, by the way. Everything that you see here, you will see some presentations as well as some notebooks, some diagrams maybe, but we changed the agenda in a way that is more applied for the real world use cases, so that whatever you learn here can be applied into real world situations. Okay. So, and then the third day, we will have more like a healthcare NLP in practice. So how to identify and obfuscate the PHI data, how to use or employ all these models for an oncology research. This is only for one use case, by the way. So we have accelerating rare disease diagnosis via human phenotype extractions. And then the last day, fourth day, Thursday, we will cover open source, visual, and multimodal AI. So we will mostly cover the visual NLP offerings as well as open source Spark NLP offerings. Let's get started. So Johnson Labs is 10 years of Johnson Labs is there for the last 10 years. So we can proudly say that we have 10 plus years of excellence in healthcare AI. This is the Johnson Labs is the provider or the developer of open source Spark NLP library as well, which has been downloaded more than 160 million times so far. And then healthcare NLP and visual NLP is already sitting on the shoulder of Spark NLP, open source NLP, and then we are a large team distributed across the world. So we are about like 125 people to provide solutions for challenges mostly in healthcare. We have finance and legal NLP solutions as well. They are also licensed library, which I'm going to mention, but we basically release every other week. So every solution and model that we have are up to date. We try to make sure that they are up to date. Whenever there is a new paper or there is a new model architecture release in academia or in research community, or we develop internally, most of the time we develop and then publish papers as well. So we try to deploy all these solutions to solve real world problems via end-to-end integration. So healthcare NLP, like our flagship library, right? So this is a library that you can use to solve your own problems with your on-prem. So everything that we are going to cover for the next 4 days are on-prem solutions, which means that whatever you see and run in a Colab notebook in our workshop repo, you can do the same on your own local infra, because we are supporting all the other infrastructures and ecosystem as well, which I'm going to cover. So in healthcare side, we have more than 2,600 different pre-trained models. They are at different sizes. Like some of them are just for entity extraction, some of them are end-to-end entity extraction, relation extraction, ICD-10 code extraction, etc. So we have more than 2,600 pre-trained models, by the way, trained by us. So they are not just dumped into our library from Hugging Face or somewhere. No, we have already in open source, we have more than 130,000 models. But in healthcare, all these models are developed and maintained by us, our healthcare NLP team. So I've been leading the healthcare NLP team for the last 5 years at Johnson Labs. So I can proudly say that we are already supporting more than 100 major healthcare organizations across the globe. So our trusted healthcare partners, which means that we did projects with them, we are collaborating with them, we are partnering with them to solve certain problems or help their own customers, right? Let's say that Databricks comes to us and then they have their own customer. We work with them to provide solutions in Databricks environment to solve that problem. So we also work with different pharmaceutical companies like Roche, Novartis, etc. So to solve their own problem by using our own solutions. And then we have a nice industry recognition as well through different awards and some solutions that we are awarded for excellence to solve certain problems. So as I mentioned, these are the top, maybe a few use cases that I can mention. By the way, anything that you see here are already on our website as well. If you go to johnsonalways.com/customers, you will see all these use cases. We are organizing Healthcare AI Summit, Applied AI Summit. Lately, we rebranded it. So every 6 months or every quarter, we used to do this every quarter, but right now, every 6 months, we have an Applied AI Summit that we cover all these use cases with the people coming from these companies. So they cover their own use cases. So if you just Google or go to YouTube Johnson Labs channel, you will see all these use cases over there as well, presented by their own product owners. So for example, for the West Virginia University, we are doing some HCC code discovery. For Roche, we did some building oncology patient timelines. For Merck, we did some on a patient experience journey, like patient journey products. For Providence Healthcare System, we helped them to identify 700 million clinical notes and so on. So we have more than 100 different use cases like this, all using healthcare NLP and Vision NLP solutions on their own-prem. And there are tons of resources to learn all this, by the way, which I'm going to mention as well. So as I said, this session, my session will be an intro session to explain, to get to know you what you can find in Johnson Wallace ecosystem and healthcare and NLP ecosystem, because we are there for the last 10 years, and then we develop many solutions to solve real-world problems in healthcare with different partners and companies, as you see on this screen. So that's why the library, the model that we are developing, are forged through real-world problems, which means that whatever we put over there that you see in the notebooks, let's say, or in your own code base, are coming from various experiences or headaches or pain points that we try to solve while helping those customers. And each one, as you know, comes with their own problem, own niche use case that we try to integrate our models, our solutions into their own workflow so that they can serve their own customers at scale, or they can solve their own problems. So if we go a bit high level, Johnson Labs is the provider of various libraries. Spark NLP is an open source library, which has been downloaded more than 160 million times so far. It is a production grade text processing library, open source already, that millions of people are already using. And on top of this, we built healthcare NLP, visual NLP, finance NLP, and legal NLP. So we mostly focus more on the healthcare NLP and vision NLP. And with this library, we provide different solutions and models. So it's not just models, it is a tool that you can build your own solution. Of course, we have medical large language models as well that you can use within the same library, small models, medium-sized models as well. We have a containerized solutions for this as well, which I'm going to cover as well. But we use this pipeline, these annotators, these modules to solve different problems. And then we have notebooks for this. If you go to Spark NLP workshop repo, you will see all these use cases as a end-to-end walkthrough, right? So which means that if you want to do medical terminology mapping, we have a notebook to show you how you extract the named entities and then map them to the entity resolution, like different medical terminologies, and then how you can dump into your own DB. Or if you want to do some medical summarization or question answering, we have a notebook for this as well. Or how to fine tune any model that you see here. Or if you want to do patient risk adjustment, because we know that with LLM era, people tend to write less code, right? So but we have a model that you can accomplish your goal end to end. But if you want to deep dive, because this is the beauty of healthcare and NLP, everything that you see is open box. It's not black box, which means that every solution that we provide here is the combination of different stages that you can plug and play and then change the nature. If you don't, for example, you would like to extract certain PHI entities, sensitive entities, if the model, pre-trained model, because they may not generalize on your own data distribution, right? So you can just go ahead and then replace that stage or fine-tune that stage and then stitch it back into the pipeline, and then you can keep the existing pipeline. So you can update the existing pipeline and then keep using it. So it's not like one single LLM that you just prompt and pray, right? So of course we have LLM-based solutions as well. I'm going to cover them as well. But the beauty of healthcare NLP is that you can run these models at scale over millions of records on your on-prem without burning any GPU, because they are all CPU optimized already. So JSL ecosystem is the combination of multiple venues. So like upper left corner is our demo page, which means that you can go to demo page and then just click on any of them and then see how different models can work. On the upper center, we have a model hub that you can find all these 2,600 different healthcare models over there by querying. On the upper right corner, we have a workshop repo. On the bottom right corner, we have a SDK for the developers so that you can understand what's happening underneath. And then we have a large documentation. You can even, we even have a deep wiki for this that you can go ahead and ask your own question, like how to build certain pipelines, etc. It will help you because there are hundreds of models right over there. And then we don't expect you to be an expert, but we have Udemy courses or Colab notebooks, like more than 200 different notebooks to show you how to do this as well. As I said, all these models and library, because if you are building a library, if you are building a software, you need to make sure that your customers, your users can use that on their on-prem, right? It's not just, okay, you can just deploy this as a Docker container. No, maybe they are using Microsoft Fabric, maybe they are using Colab, or they are using Databricks or some other ecosystem or dependencies that we may have that they may have an issue to introduce latest tech stack, right? Because I have seen many use cases that people are working in some infra behind firewall, they cannot even do any pip install. So when you have the library, for example, healthcare NLP, you don't even need to do any other pip install as long as we deploy everything over there, because we share the wheel files, jar files, etc. And then when you deploy, the only things that you need is models. You can download the model. You can download the models offline and then ship into your on-prem and then go into an air-gap environment and then start using it. For each of these ecosystems and infra that you see on this screen are already tested, and we have solutions over there. For example, for Snowflake, we have different solutions, like a same name identity recognition model or LLM can work on Snowflake with a different solution. In Fabric, we have another, but everything is using the same library, so you don't need to plug and play anything. We even work with data EQ or Synapse ML, which means that we tested our models and code base in those infra so that they don't conflict with their own dependencies. Of course, since we are saying we provide state-of-the-art latest models in healthcare AI, we need to prove this, right? That's why we have publications. We publish regularly. For the last 7 years, we publish more than 60 different articles. So they are all peer-reviewed. You can go to our website and then click on a peer-reviewed publication. You will see all these publications, which got more than 2,000 citations so far. So those are the, like, bottom right corner, you see the top publication menus that we publish, that we submit our papers. Sometimes we wait 1 year to get it published because of competition. Sometimes we get like in a month if it is not outdated. So some topics are usually outdated when they are published. But we proud to say that those are the top publication venues we usually pick, and then we manage to publish our research over there. And then research breakthrough, like areas breakdown are, so we publish on clinical identification, medical name identity recognition, how we evaluate our medical large language models, and other problems that we try to solve in healthcare AI. So we try to publish papers on this that you can also go ahead and read. These are some of those papers that we recently published in the last few years. For example, we have clinical LLM evaluation by expert reviewer. We call it Cleaver. We submitted into Jimir. And then we have several de-identification publications as well, how we do the obfuscation, how we do the de-identification, how we ensure the consistency across different modalities for the identification. And then we try to explain how we do this so that nothing is black box. We share the metrics, we explain the methodologies, we share reproducible notebooks so that you can reproduce all these benchmarks as well. And then we try to give you some other ideas that you would employ in your own use cases, so that it's not just there to show off. It is there to help the research community to benefit from this as well. We regularly publish at conferences as well. We are invited sometimes and then have a talk over certain use cases that we help in real world situations. I strongly suggest you go ahead and then check our Applied AI Summit recordings at YouTube, because there are hundreds of different use cases that you can get to learn just by watching a 20 minutes videos over there, rather than just marketing videos. They are real world use cases presented by the owners of that research from that companies. So, as I said, there are many resources if you would like to learn how to build such solutions in your with your own data without even letting us know, so that no one can see your data, and then you can run everything on your own prem. So we have Udemy courses as well. For open source NLP, we have Spark NLP for data scientist course. We have healthcare NLP for data scientist course as well, that you can go ahead and then subscribe and then learn. But all of them are already, we have a notebook. All these notebooks are already open source in our Spark NLP workshop repo tutorials MOOC notebooks. This is the path to the notebooks, by the way. So let's get into the healthcare AI, because for the next few days, you will get to learn how to employ different solutions to solve your own problems, right? So I would like to do some brief intro to healthcare AI, why we are trying to solve certain problems, and what Johnson Labs offer, or what kind of tools that you will find and learn for the next few days. So as you see, we are in the like if maybe people say that fourth industrial revolution, but looks like it is the fifth industrial revolution that we are integrating AI tightly into our daily life, right? So right now there's no one in the world that doesn't know about AI, probably due to the for the last 3 years, especially with the advent of ChatGPT and LLMs, people started to talk to integrate AI into their workflow every other day, and then there are many other solutions built around these models, we call it Gen AI models, right? So, and this era, rather than muscle or physical labor, skill-based mindset, and then adaptation to AI mindset, or adaptation to the solutions provided by the tools that we are using every day, is more important than being able to develop them sometimes, right? So as everyone says, AI will not replace humans, but it will replace the humans who are lagging behind when they try to employ AI into their own workflow. So that's why the talent requirements change, given the inflection point that we are experiencing for the last few years. So how did this evolution of AI in healthcare happen, right? So it's, of course, AI started in 1950s, so I'm not trying to go into how neural networks are designed, how the perceptron works. I'm not going to go into that detail, but AI is as old as 1950s, after the World War II. And then there were some rule-based and expert system at first. Then but by the end of 1990s, there are statistical machine learning era started, and then all the HR nodes are digitized with the help of digitization effort incentivized by the governments in 1990s, and then predictive analytics started to be applied into every workflow. Especially in 2010, there is a deep learning era started with the help of AlexNet and ImageNet competition. And 2020, there is an age of transformers. And 2024 and beyond, with the help of Gen AI, with the advent of Gen AI, we have multimodal LLMs to accomplish multiple tasks at a time, and then we have agentic workflows to solve certain problems without even writing a single line of code. So right now, ambient solutions are everywhere. We are trying to integrate these solutions into our workflow every other day, as you see. So data in healthcare systems are multimodal. Their nature is multimodal because when you try to solve a problem, you don't just rely on one text data, right? So you have an EHR data. If you have if you are working with a healthcare, like if you are the data provider, data owner, you probably are using EHR data, and then, or if you are a healthcare analytics company, you are probably dealing with the data that is already exported from EHR. So this data is not the only source of data, even if that is the source of the data, like origination point, but there are many other data exchanged and created down the road, right? So there are some clinical trial going on, so there are some new data generated based on different post-processing, right? You extract the data, create a cohort, you extract different ontologies, let's say cancer trial, you extract some cancer staging information. Now you have a new data source. So, and this data comes from structured and unstructured, even voice data. So to be able to tame all this data and ingest into one workflow, you need the holistic approach, right? So that's why multimodality in healthcare is quite important, because as a physician is when he's making a diagnosis, right? He's not just looking at one single node or one single visit. He or she is checking the entire timeline of a patient, especially the history of the patient, by checking all the other evidences. And if we just rely on one modality, if we try to automate this process, right, we are missing the main point here, and then we are losing all the other opportunities that AI can provide. That's why right now every healthcare institution try to integrate some multimodal solutions into their workflow. Before Gen AI era, as you know, we were trying to stitch everything together, which is still can be done if you want white box solutions, which we are also providing here. But nowadays, with the help of multimodal LLMs that can ingest text data, image data, voice data, etc., you don't need to jump from one model to another, or most of the time you don't even need to train a model with your own data. But if you have most of the time that's the use case, by the way, if you have a resource limitation on your infra, if you don't have enough computation power or enough technical expertise, you may not need to tame this kind of 70 billion size, 300 billion size of models. If you want on-prem solution, you need to find a way to deploy this solution. That's why there is a small language models concept that we fine-tune. We have out-of-the-box pre-trained small language models over there, by the way, that we fine-tune for certain medical tasks. I'm going to share some benchmarks as well. So you don't need to boil the ocean. If you have a specific problem, you can just distill one of the large model into a small one and then deploy into your own solution. Why are we building this timeline, right? So if we manage to put the clinical facts on a timeline, we can use all these AI solutions to predict the next stage, or because physicians, like healthcare providers, are doing this on the fly every day, right? So they have a timeline. When a patient visits a clinic, there's a timeline that a physician needs to consider when making a decision. So if we can automate this stage, and at each stage, if we manage to extract different data points, right? Like imagine a breast cancer patients who have been visiting the clinics for the last 5 years, right? Probably there are hundreds of, maybe thousands of notes already generated. So if you are trying to extract certain staging information, you need to see all entire timeline, and then by extracting these information, you need to stick to certain guidelines like AJCC, SEER guidelines, cancer staging manuals, etc. But when you are doing this, if you are only checking the radiology notes, you are missing the pathology notes. If you are only checking the pathology reports, you need to check the corresponding radiology reports as well. That's why building such a timeline and journey quite important to have a solid pipeline so that you automate certain data abstraction process automatically rather than manual efforts. Last week in the Applied AI Summit, I have a session how to do this for a cancer registry. You can go ahead and then watch that recording on YouTube as well. So we try to show over there how you can how you can go from 2 hours to 2 minutes with the help of solutions that you can build on your own prem as well. So basically, when you have an unstructured EHR data, like a structured EHR nodes, unstructured nodes inside the EHR, fire nodes, etc., they are all coming from different hospital and data sources. And then the goal is map them into a common format so that this data can be put in a sequence, temporal sequence, and then we can use this to answer certain questions, right? If I have a data that I would like to query, like give me all the patients who have diagnosed with COVID and then also had CT in the last 3 months, I need all these modalities. But it is said that the systems used to generate health data in these healthcare providers are designed for operations, right? Because their job is not to utilize the data. Their job is to serve their patients as fast as efficient as possible. So which means that this data initially not organized effectively for research or analytics. That's why when we talk about healthcare data, we are talking about another level of unstructured data that is hard to tame. That's why we have too many startups out there trying to offer solutions for each problems that healthcare domain is suffering right now. The data over there is not designed for analytics purposes, but our job here as developers, healthcare AI scientists, to build a pipeline to get over this drawbacks of unstructured data. But no matter what you do, no matter what pipeline that you build over there, you cannot answer even this kind of simple, like even if you dump everything into an LLM, right? Right now, people tend to dump everything into an LLM. Even if you manage to deploy 5 years of patient journey, like dump 5 years of patient journey and into one single LLM, let's say GPT-5 or Gemini 3.0, right, which is going to come probably this week. Even if you have 1 million token context window, you will probably not able to answer this simple questions, like give me all the patients who have type 2 diabetes using metformin, doing this and that, right? Because all this information might live in certain tables, certain unstructured nodes, so that you need the entire journey. And it would be a waste of effort if you try to dump this data again and again into LLM context window, right? So that's why you need to build, if you build an entire journey, if you build a nice knowledge base around this, and an infrastructure around this, you would be able to ask the same question and then get more reliable results. By using LLMs orchestration power, right? We are talking about agentic workflows nowadays, right? So agentic workflows are there to build an agent frameworks with your own rules, so that you have a hybrid solution over there that you can accomplish certain tasks with the help of LLM, but not relying LLMs on parametric knowledge, but using LLMs orchestration and then some text understanding capabilities, right? So that you have the whole control. That's why we built Total Patient Journey right now with the tools that we are offering at Johnson & Wales. As I said, Johnson & Wales is not just providing the libraries or models. We have our own solutions as well, like Gen AI Lab, Total Patient Journey, chatbot. We have other solutions coming up as well by the end of next year. So we will have several other solutions. We have the identification solutions as well, and so on. So this is briefly an intro for the patient profiling. We call Total Patient Journey. Every colored circle you see here represent different modalities, right? So the yellow ones are unstructured text notes or PDFs or some screenshots, right, maybe. And blue ones are already like structured notes. And maybe you have data in file format. So if you would like to ask a question like a boy younger than 12 years old with BP less than 112, etc., with this kind of criteria, if you would like to query your data and return a list of patients like a subcohort, you need to utilize all these data. That's why we are offering solutions right now, all these like whatever we built at Johnson Controls, by the way, you can build the same solutions with the tools and models and library that we are providing over there, because we are building those solutions as well with our own tools. So which means that when you have the library, you would be able to build such a solutions. Of course, problem solving is another step that we can collaborate further. But basically, we are trying to build a patient journey, building all the available resources so that you don't need to stitch things together again and again. So as you see, yeah, this is a paper coming from like 2015, right? The little red block at the center represents the machine learning code, let's say AI code, like LLMs, Gen AI, whatever you call it. It is just a small part, maybe the engine, maybe the most important part, but it cannot do anything by itself, right? You need to build an entire infra around this. So only a small fraction of AI system solutions is the model itself. That's what I'm trying to say here. Because when you use ChatGPT, for instance, it is a system as well. It is not just one model, because there is a GPT-5 or GPT-4 model behind that, and they build an entire solution and call it ChatGPT. So when you talk to any AI, unless you deploy it locally, the model itself, model checkpoint itself, you are talking to a system, not the model itself. And then they provide some API endpoints. We have these solutions as well, by the way. But when you build a solution to solve certain problems with the help of Gen AI tools or models or machine learning models, you need such a complex systems. For example, this is one example from Google Cloud. So the bottom right corner, you see a foundation model, but to be able to, let's say you would like to build some UI to upload your own documents and talk to this document. And this is there is such a complex system over there that you need to know how things work. Most of the time people use this via API, but if you would like to build such a solution on your own prem, you need engineering skill sets as well. That's why we are trying to educate everyone in healthcare AI, and that's what we are going to learn for the next 4 days. So we will touch upon some of the points that you see here so that you can build your own solutions as well. This is just one example, by the way, just to show the complexity of the entire system. So how we are building such a solution, as I said at the beginning, so we are more than 100 people over there. When you use our libraries, you probably know us through Slack, through email, through different channels. We would like to get in touch with you. You can just, as long as you use the library, we are there to help you. We try to, if there's any issue that you report, we have a record ticket closing. Right now 95% of the tickets are closed less than 1 day, so we have a strong support team during the next 4 days, by the way, while we are presenting our solutions, all these models and infrastructures, etc. There is a support team supporting us behind the stage right now, who are answering the questions that you are asking right now. So if you ask a question, you will probably get an answer right away, because we have a support team try to help you with all these questions. So feel free to ask. These recordings will be shared with you afterwards. We will publish them on YouTube as well, so that you can build your solution. We can build this solution together, probably. So let's go over to models and LLMs. So I have like 10 minutes left, so I will try to cover some healthcare NLP and large language models that we built at Johnson Controls with through all these projects, hundreds of customer-facing projects that we forged so far. So we have 2 eras, right? So you might say that at Gen AI era, why do we still need NER models, name and entity recognition models? Because I can just dump this sentence to an LLM and then extract everything that I see on this image, right? Like extract assertion status, nomad code, ICD-10. But that's a misconception. If you are using LLM right now, you are relying on its own parametric knowledge, because it is the representation of entire world, like all the tokens that it's trained on, like a web data. So there is no selection of the data source. They have some data creation that they apply, of course, but you might end up with a SNOMED code probably learned from Reddit post. You may never know that, especially for this kind of mapping. And if you are not rich enough to deploy large, like 300 billion size of model, you are probably using 70B, 50B, 30B size of models. Their medical terminology mapping is quite low, for instance. Or entity extraction capabilities are quite low because whatever you called as a symptom might be a sign for another healthcare institution. Whatever you called as a clinical finding might be named another one, right? So that's why you need small size, maintainable, fine-tunable models on your own infra. That's why we have more than 2,600 pre-trained models and pipelines still you can use. Of course, we are using LLMs as well, right? On the left side, we have different solutions like total patient journey, generative AI lab, etc. And we have different size of models as well, like specialized small language model, which is less than 10 billion size, that you can go ahead and then use with the same library that you see on the right-hand side, which means that we have LLMs to extract entities as well, but we fine-tuned that LLM to extract entities. So it's not just, you know, we have another LLM just for summarizing the radiology notes, for instance, because if you fine-tune some decent size of LLM for a different task, you can you can reduce the size of the model, as you know. That's why the specialized small language models are doing way better compared to large language models for that specific task, because you cannot just expect a GPT-5 size of model to solve your own problem because it hasn't seen your own data, right? But if you have a small model that is fine-tuned on your own data, own pattern, you can do more stuff than a large model can do out of the box. So we have different size of models, as I said, like a 14 billion to 18 billion size of model. We call it MEDM, like a medium-sized medical LLMs. They have different license, but we have small language models that you can use as if it's a NER model with the same healthcare NLP library, by the way. You can even extract, as I said, entities with some LLMs if you would like to test. But on the right-hand side, we have, like, we support more than 50 different medical terminologies, for instance, because over there we have a open box pipeline, like we extract the entities and then we try to map these entities within its context to a certain terminology, because we have a different vector DB for each terminology, by the way, that you can accomplish the same within the same collab notebook that we will provide here. So if you go to Spark NLP workshop / healthcare NLP folder, you will see all these notebooks, how you can do the same. I'm going to upload like a 60-page slide into certification training folder as well. On top of this presentation that I'm showing right now, I prepared another one, which is going more detail into GSL ecosystem and healthcare and NLP ecosystem. You can go ahead and then check that PDF as well on your own time. So if we split this ecosystem into 4, the upper left corners are LLMs that we just mentioned, medical, specialized, fine-tuned LLMs. Upper right corners that we have been already developing for the last 7 years. So like they are encoder-only BERT-based models, right? We have encoder-decoder-based T5 and DeBarta or BART architectures as well to do medical summarization, question answering, text generation. Surprisingly, we are still using all these small models without even using any LLMs. For LLMs, we are building some other flows to solve different problems that small models cannot do, right? So if you would like to do build some RAG architecture, talk to your own documents, the other models may not help, but a small 3 billion size of model can be deployed in your RAG architecture. On top of this, we have out-of-the-box solutions as well, which means that we have some certain solutions that we ship out of the box they are already baked in, which means that we build certain solutions to solve certain problems and then we ship it to other infras as well, like some turnkey solutions, we call them. So if you want to do medical text-to-speech, we have a pipeline for this. If you want to do HCC and risk adjustments, we have another pipeline for this. We have medical terminology mapper. We call it terminology server. So we have web-based, the 4th pieces, we have UI as well, like a web-based applications that you can deploy on your on-prem as well. So we have medical chatbot, generative AI lab, terminology servers. Generative AI lab is there to, you know, annotate your own data, human-in-the-loop validation, train your own model within the same platform, so that you can, without even writing a code, you can fine-tune any NER model or train any name identity recognition model within the same platform. You can even annotate your data with LLMs as well as your own, like our pre-trained pipelines. We have total patient journey and patient registry products are coming up as well in a few months. So it is the pillars. They are the pillar of what we have been cooking here for the last 10 years, by the way. So as I said, everything starts with information extraction in NER, in healthcare NLP, in healthcare AI. And then right now, even the tools and model sizes and model capabilities change, the task is still same. Extract information, extract insights from your own unstructured document. But we do this extraction for a reason, right? We are not just extracting the entities to highlight the text, right? So if we extract these entities, we dump them into somewhere so that we can query, we can build other solutions on top of this. Maybe I'm going to build a total patient journey. I need all this data from unstructured nodes so that I can merge with the structured data and create a new schema, let's say OMOP schema, right? So that I can connect my own solution UI to that DB and then use on the UI. Or maybe I'm trying to automate medical terminology mapping. Maybe I'm doing some insurance claim analysis. I would like to know that if there's a fraud over there, so I can upload a document and then find all the possible ICD-10 codes, HCC codes, right? So to be able to do this, I need to extract all these entities. I need to map them to certain terminologies so that we help human to inject this automation into their workflow so that they don't need to visually check, because sometimes there are thousands of pages to explain what stage 2 means for a certain type of cancer. So that's why the medical coding is a specialized profession, by the way. People get trained to do this. That's why we try to automate all this process. And we already have more than 500 different small name identity recognition model that you can extract all these entities, like more than 500 different entities you can extract. Of course, you can say that, okay, you can just dump this into an LLM and then extract. But if you are doing, let's say, oncology entity extraction, if you have millions of records, if you use LLM for this, first, you need to make sure that whatever you get from there are deterministic, which are not. And then you can scale this over millions of records, which you cannot do with large language models, right? That's why we have solutions on top of small language models and very small classic NLP models like LSTM-based NER models, that LLMs are playing an orchestration role over there rather than handling the data extraction. So LLMs are there to build an interface between you and other AI models. And there are some tasks, of course, that cannot be done by small models. That's why LLMs are there to help you, let's say, talk to your own data, or extracting certain information that can be inferred, right? I can extract all the tumor-related entities, for instance, but maybe there is no staging information over there. But if I instruct LLM well enough with this corresponding guidelines, and then feed all these granular entities that I can extract with NER models, I can help LLM to make that decision so that it can connect to us, right? Because LLMs are like a JPEG images, right? They are zipped version of the entire world, which means that whenever you try to get information from LLMs, you may not know if that's why we call it hallucination, right? So that's why if you add some guardrail to these models with the help of small models, you will probably utilize LLMs way better than out-of-the-box LLM solutions. So we have some benchmarks over there to compare our entity extraction capabilities compared to other LLMs like GPT-4, etc. So as you see, we are already outperforming them on these verticals. We compared ourselves with the cloud providers as well. So because AWS, Azure, GCP, they all have their own healthcare API. And LLMs like Anthropic Sonnet, GPT 4.5 or GPT-5, they have their people tend to upload their documents and extract all these entities as well. We did some analysis on certain entities. We see that specialized small entity extraction models are still doing better compared to large language models. But if this is the goal, if the end goal is extracting the entities, right? But if the end goal is different, let's say summarization, NERs will not help over that, but NERs will help summarization to ground so that the hallucination doesn't happen when LLM summarize this document. So we have a data and the identification solution as well, like finding the sensitive entities and replacing them with the fake corresponding entities by keeping the consistencies. So we compared this against other cloud providers and private LLMs, and then right now this is the most most robust solution that Johnson Controls is offering right now, because this is the best-selling product, by the way, that we have running the identification solution with many other customers and users around the globe right now. And we are supporting already 8 different languages like Spanish, Portuguese, French, etc. So how we evaluate all these models, right? So there are some evaluation frameworks like Stanford has MedHelm, and then OpenAI has HealthBench, etc. So there are different data sets under each frameworks. For example, for the clinical documentation, there's an empty sample, ACI bench, MEDEC, etc. For clinical dialogue, there's another data set. So that's why there are benchmarked like a test benches that is combination of multiple data set for different medical tests. So we try to evaluate our models, small models, against all these large language models on these verticals. And then this is run, by the way, last week, by the way, GPT-5 versus Gemini 2.5 Pro versus Sonnet 4.5, which are the latest at the time of this presentation, which were the latest state-of-the-art private LLMs, frontier models. We compared our solutions on these data sets. By the way, we are going to provide you the endpoint so that you can reproduce this as well. So we have our, like, this is medium-sized LLM, without even using any data from these data sets. We built these solutions around some system. As I said, when you talk to ChatGPT, it is a system, it is not the model itself. That's why we have some system built around our own LLMs as well, that you can deploy on your infra. These are the metrics. So to wrap up, how we deploy these LLMs, how you can deploy all these LLMs in your own prem, right? So there are 6 different ways of doing this. We have hosted demo apps that you can just ask us to get an access so that you can test our LLMs on our demo apps as well. We have containerized deployment that you can deploy on your own prem. Let me turn on my camera so that I can wrap this up. We have containerized deployment, even supporting some like Databricks infra as well, which means that you can just take this container into your own infra and then run with your own data without even letting us know. So we have marketplaces as well. So in AWS marketplace, like you can just pick any model that we offer over there. If you go to AWS marketplace and then search Johnson Controls, you will see all our marketplace models, which we are going to cover in the next few hours, by the way, as well. Again, whatever I have tried to cover during this session, you will learn all this for the next 4 days. Of course, it's not enough. That's why we have 200 different notebooks and hundreds of hours of tutorials on YouTube as well, if you would like to learn more. So we have available small models for local use. Let's say you would like to test it on a collab or on your own local laptop. You can test all these models over there as well, by the way, because we have a LLM loader inside Healthcare NLP that you can test this. And we have an API endpoint coming sub as well. So far, Johnson Controls hasn't offered any APIs-based solution because we always claim that, which we still believe, anything that we develop should run on your local with no internet connection due to the nature of the data. But to make the testing process easier, not building a solution around, just to test this without going into any deployment or any installation process, we will try to offer some API endpoints soon as well so that you can test all these models remotely with your own non-PHI data, of course. So I'm not going to get into how foundational models are built because we are running out of time. So that's the process that we apply right now. We pick some backbone foundational models and then try to fine tune it with different optimization techniques and different data and data sets and then different instructions, so that we have our own small language models that can accomplish certain tasks very well than the foundational model itself. These are the resources that you can go ahead and then use, check out. So we have official documentation, we have getting started guides, we have learning hub, so we have Medium publications, we have deployment guidelines. So you will get this PDF, you will get this deck as well. So you can go ahead and then check all these links as well. If you would like to learn and then solve solutions, of course, it may not be easy to find your way around all this documentation. That's why we have a strong support channel like Slack channel, email channel, etc., so that you can ask questions, so that we can point you to right resource. So far, I tried to explain what you can do with the small language models versus private LLMs versus open source LLMs, right? So this deck is there to compare when to use small models, even without any LLM, like just simple relation extraction model, maybe assertion status model, versus LLM. So I try to cover on this deck, so you can go ahead and then read later on. Probably we will not have enough time to cover all this. I hope you enjoy this training sessions. So we will have 15 more hours together. My colleague at Johnson Alves will try to cover their own sessions, and you can ask any question during this session, so that I will be one of the support person as well to answer those questions. Please go ahead and then test all this, like we are sharing all these decks and notebooks with you as well in the corresponding GitHub repo, so that you can test on your own date and own time. You can rewatch all these recordings later on as well, or you can reach out to us whenever you want, so that we can help you build your own solution by using all these models that are built for the last 10 years through different projects. Thank you very much. I hope you enjoy the rest of the certification trainings.
Thank you, Vaisal. We're going to take maybe 5 minutes break, and then we'll jump into our next session, which is medical language models, private API endpoints. Kshitis was not available to join us, so he made a pre-recording for us, and I will turn it on in about 5 minutes. Just a reminder, if you have questions anywhere along the way, you can drop them in the chat, and one of our team members will get back to you. So 5 minutes from now, we'll get started. Sorry, we'll continue, not get started. All right, I think we can continue now. Let me know, please, in the chat if you have any issues with hearing the session, and I'll get started.
Hello everyone, my name is Satya. I'm a software engineer here at Johnson Labs. Currently, I am a lead engineer at our integrations team. Our team focuses on building and packaging our state-of-the-art medical language models on different cloud providers. In this session, I'm going to try to cover these topics. First, JSL models as API endpoints. In this topic, I'll explain to you why it's a good idea to start using JSL models as API endpoints over traditional approaches. Then we'll be looking at some of the deployment options we offer. First, we'll look at the AWS Marketplace. I'll show you what listings we are there on the AWS Marketplace, how you can subscribe to it and start using it. Similarly, we'll look at the Snowflake Marketplace. We have a lot of listings there as well, which you can start subscribing and using on your Snowflake infrastructure. It's a simple process. I'll show you how to do that as well. Then we'll look at the Azure Marketplace, which we recently started working on. We have some LLMs published there. I'll show you the deployment process there and how you can start consuming it. Right. Then we'll look at an on-premise deployment. So if you don't have access to any of these cloud providers, or if you want to start using something locally, we have an on-premise deployment as well. That is, with a Docker image, you can start exploring our LLMs, right? So it's a good way to get your feet wet. So we'll be talking about these topics, right? So I'm going to turn off my camera and I'm going to start with the first topic, which is the JSL models as API endpoints. So JSL models as API endpoints, there are a number of advantages over traditional approach. First is the privacy aspect, right? Since we are on a healthcare domain field, right? Our models and endpoints need to be, our solutions need to be HIPAA or GDPR compliant. Right? Since the API endpoints are deployed on your infrastructure, you can be rest assured that no sensitive data is ever leaked to us, meaning nothing ever calls back to us. The endpoints are hosted on your infrastructure. You can send your data through that endpoint and be assured that nothing is sent back to us, or we don't collect any telemetry or information regarding what's deployed on your infrastructure. You have mechanisms in place on the cloud provider side, meaning on AWS and Snowflake and Azure, you can have a network isolated environment as well. So you can be rest assured that your data is private to yours only, right? Another aspect is the effortless integration, right? Since these are generative endpoints, you can make some calls to the endpoint using REST APIs, or for our cloud providers, they have their own SDKs, right? That you can use in any programming language, for example, right? So you don't need to just stick with Python. If you are comfortable with other programming language, if the endpoint is hosted, you can use any programming language of your choice that the cloud provider supports, and you can just make calls to the endpoints, run your data through it, run the inference, or get the outputs that you are looking for. Another aspect is the speed aspect, right? So for traditional approaches, you probably need to create some pipelines and just test around with the model, or test around or install dependencies. So that would have been required in the past using traditional approaches. But with the new, with the private API as endpoints, with a few clicks of the button, you can have the endpoints running on your infrastructure. The endpoints are state of the art. You can just run your data through the endpoint or whatever you want. You can have it integrated on your workflows. So that's why speed, there's improvement on the development types, development cycles. You can just focus on what your needs are and let the model run as a separate entity maintained by us, but on your infrastructure, so everything is secure, right? Another aspect is the maintenance aspect. Since we are the publisher of the models, whenever there is a new model that is better performing, that are created by our data scientist team, we make sure to update the models and make sure all the security patches are in place. Everything is on the marketplace side, so based on your need, you may choose, or based on your need, basically you have the flexibility of either switching to the updated model or just staying on the previous version. So everything is supported through the cloud providers endpoints. So yes, we do frequently maintain our endpoints or models, right? And there is the scalability aspect. Since our endpoints are hosted on those big cloud providers, they have scalability built in, right? So you can choose a lot of so you can have auto-scaling clusters based on the number of endpoints you would like. For, let's say you have a high bandwidth of data that needs to be done. You have abilities to run multiple endpoints, run batching operations, right? And everything is taken care of by the product provider. You can have auto-scaling cluster that, depending upon your load, either may scale down the number of nodes that's handling the request, or scale it up back up, right, depending upon your needs. So these are the advantages of using API endpoints or JSL models as API endpoints. So next is where you can find those models. These models are available on our Johnson Labs website, or Models Hub website to be exact. So I have a link added here. On clicking the link, you can see our Models Hub page. Also, the links are out as on the slide, so you can see it exactly. So these are all the models that we currently have on our Models Hub. 140,000, but all these endpoints, all these models are not available as marketplace product. To find the marketplace product, you have this marketplace filter here. You can use this to find the models which currently are supported as APS or a private API endpoints through the marketplaces, right? So this is how you can find the models on our Models Hub website. Now on to the next topic, which is private API endpoints on the AWS marketplace. Currently, we have around 58 plus endpoints available on the AWS marketplace, and we are still trying to add more. They range from medical LLMs from 7B to 70B. We also have vision LLMs, right? We also have de-identification endpoints there for 8 languages, from English, Spanish, German. The de-identification models also have multimodal capabilities in terms of we have endpoints for de-identifying PDF files, images, SVS files, DICOM files, etc. We also have medical translations on the AWS marketplace for English to Spanish or English to French and vice versa. We have entity relation assertion detections, NOR pipelines, relation extraction pipelines, or certain detection endpoints. All those are available on AWS Marketplace as of now. The thing about the AWS Marketplace is you don't require a JSL license to get it working, right? So typically, if you have used our Johnson Labs products, you would know that most of our products are most of our models are proprietary, and you don't require a JSL license to get it working. But the thing about these cloud providers, we have a partnership with them, and our products are there without the use of a JSL license, right? So everything is taken care of by the AWS Marketplace itself. So you go there, you subscribe. I'll show you the process in a few minutes. So another thing to notice is the deployment aspect. You actually don't need to write any code to deploy. You can, but with AWS Marketplace, with a few clicks of the buttons, you can have the endpoints running on your environment, which I'll show you. And there is, as I mentioned before, everything runs on your AWS infrastructure, right? When we create the listing, we provide the best recommended infrastructure that would be required to get an endpoint up and running for that particular model, right? And once we have that, when you launch an endpoint, you have the option to pick the instance you want based on your needs from the list we recommend, right? On AWS, you have the capability for real-time and batch transform jobs, right? So real-time jobs, real-time inference jobs, or real-time inference endpoints are useful when you require high throughput, right? So you have a request and you want the response within some seconds. So in that case, you have the capability to use a real-time inference endpoint, which is you send a request, you get the response right back. So if you have a chatbot like app that you need to create, or just you want to send real-time requests to the endpoint, then real-time inference is the choice for you. Batch transform jobs are for when you have a lot of documents, right, and you want it to run it through our pipeline or from our model on that endpoint, right? So in that case, you would typically use a batch transform jobs where you store a lot of data on the S3 bucket and it gets processed through our endpoints using batch transform jobs. I think they have some batching strategy there as well. So since we use AWS, these are provided out of the box. You may or may not use it based on your use cases. Another advantage on the AWS infrastructure is the integration with AWS services, right? So you can constantly monitor what's going on with your endpoint using CloudWatch and see the logs using CloudTrail. You can set up alerts, everything. It's totally integrated with the AWS services, right? So to find, I have added a link here, which will point you to the AWS marketplace page, right? If you click on this page, it will redirect to the AWS marketplace, and you can see all the listings we have provided on the AWS marketplace, right? So you can see we have the identification for PDF, we have Medical LM medium, we have Medical LM small 14B. I'll show you the process of how to deploy a model on the AWS marketplace. Okay. So for AWS, let's deploy our medical vision language model. We have a 24V medical visual LLM model. So let's look at this model. So this 24V parameter vision language model combines both medical expertise with visual comprehension capabilities, right? So it can take images, right, of specific formats like JPGs, PNGs, and it's able to process those images and text as well. And the model presents high performance in medical tasks, while adding the ability to examine visual content such as X-rays, MRIs, pathology slides, and medical diagrams. So it has a 32K context window, and you can see the accuracy and performance metrics that have been measured and put on the listing. Right? To get started, and to subscribe to your model, you need to click on the Continue to Subscribe button. You do need to be logged into your AWS account, by the way. Right, so I'm going to quickly log into my AWS account. So once you are logged into your account and you click on the listing page, you will be directed to this form where you are going to subscribe to the product. The prices are per hour, right? So you click on the accept offer button, right? This starts the subscription process, and the listing, the endpoint, will be available as a marketplace subscription on your AWS account, right? So this does take a few minutes. Let's wait for it. So once you are subscribed, you'll see a screen like this thanking you for subscribing, and now you can start using the product. To use the product, click on the Continue to Configuration at the top. This redirects you to the Azure. This redirects you to the AWS launch panel, right, where you can have option to how do you want to start an instance. So what happens is when you subscribe to the model, an ARN or a resource identifier is created to you, and AWS resource number is created for you. You need to be aware of this resource number. So this is your model package, right? So you have different options to start the model. You can choose CloudFormation, you can choose SageMaker console, or you can use AWS command line interface as well if you want programmatic access. I prefer to use the SageMaker console, which is the easiest one, but you can use any launch methods that you are aware about, right? So even on the SageMaker console, you have two options. One is the real-time inference endpoint, one is the batch transform job. So as I mentioned before, real-time inference is useful when you want to have you want to send the request and get the response right away, right? And whereas the batch transform jobs is useful when you have a data set and you want your you want your data to go through the model on a batch request, and you don't care about the response of the model, right? So it does take time. For LLMs, it is generally better to use real-time inference endpoint. So to get it started, just click on create a real-time inference and click on view in Amazon SageMaker. Now this opens a form to create an endpoint for your subscription, right? Basically, to create an endpoint on AWS, first of all, you need to create a model. The previous subscription that you did provided a model package. Now, first step is to create a model out of it. So let's use the model name 24B vision model. Can be anything you want. You do need an IAM role just to make the vision model. We need to download the proper S3 artifacts, the artifacts from the S3 bucket. So make sure you use the IAM role that has the permission to AWS Marketplace, right? After this, you can click on the next button. The next section is the continuation for the create endpoint. To create an endpoint, you also need an endpoint configuration, right? So it's asking for endpoint name. So let's use 24B vision endpoint, right? It can be anything you want. You have the option to either create a new endpoint configuration or use an existing one. So I'll create a new one for this one. I'm going to change the instance type here. So I'm going to use one of the larger ones, but all those are also supported, by the way. Okay, once you're happy, just click on the create endpoint configuration button. This will create an endpoint configuration which you can reuse later on as well. And next step is to click on the submit button, right? Once you create an endpoint, it will show you the success message. It does take some time for the endpoints to get started because AWS needs to provision the infrastructure, download the models from the S3 artifacts, and launch and container, right? So and after the endpoint is created, let's wait for it. I'll also have a demo environment where the endpoint is already loaded. So I'll be using that to show you how to use the endpoint. Okay, I'm switching to the demo instance I have, demo endpoint that I have. This is the same 24B model we subscribe to. So I'll be using this model and showing you how to use it, right? So if you have SageMaker Studio, you could actually call it via a UI. But since we have this URL, this URL, AWS allows to use SageMaker SDKs to interact with the model. Right? So you see we have uses here. Now with every listing, you have an notebook that is attached on the listing page to see how you are going to utilize this model, right? And for this listing, we have the notebook on our Spark NLP workshop playbook. So it's on the SageMaker models, the Vision LLM, right? So it's Vision VLM 24B. Okay, this one. This notebook you can use to start interacting with the model. Basically, you have the steps required to get everything from subscription to start utilizing the model. So I will use this model or this notebook to show you how to call the API. Okay. Okay, let's start. Okay, so let's use this notebook. So I go to a notebook, a SageMaker notebook instance. I'm going to launch a Jupyter Live instance. Using a SageMaker notebook instance is easier because you already have pre-configured SageMaker session, and you can use directly that to access the endpoint, right? But it's not the only case. You can use any notebook or any Python shell or any programming language to get a SageMaker session with the proper credentials that has access to the endpoint that you just created, and you can just start running it, right? So, so this is a notebook, right? So here what you need to do is you need to identify which endpoint you are going to call, right? So our endpoint is called 24B Vision Endpoint. So I just put the endpoint name as here. So I'll start this. So this is creating the required SageMaker session, the account ID, the bucket if you need, the SageMaker runtime, which is important. So basically this is using both the 3 API to get to initialize those sessions from the SageMaker notebook instance, right? And as I said, it doesn't have to be a SageMaker notebook instance. If you have the proper AWS credentials, you can do it from any both the 3 API or any notebook or from your local computer Azure, right? So to invoke the real-time inference, SageMaker provides us this invoke endpoint function on the SageMaker runtime client, right? Here you just need to provide the endpoint name as a parameter, the content type it accepts, and the content type it is responding back with, right? And you just need to send the body, which is the record. So I just created a helper function here. So I just create a system prompt as well that's going to instruct the LLM to perform based on the prompt, right? So first of all, I'm just asking a simple question: what should I do if I have a fever and my body aches, right? So you create a payload like this. As I said, this model, OPT/ML model, is required to make it compatible with OpenAI's input format. This is basically the place where SageMaker mounts the model, right? And these are the messages. So I have created a system prompt based on this, and I'm passing the prompt as a max tokens is the maximum number of tokens that the LLM is expected to return, right? And temperature just allows the randomness of the answer, right? It increases or decreases the randomness. So this is fairly common for all LLMs. We have the same thing here as well. So I'm just going to call the invoke endpoint function, the helper function I did, and I'm going to invoke the endpoint, right? Okay. So the question was, what should I do if I have a fever and my body aches, right? So it's going to send requests to the LLM, and all our LLMs on SageMaker are powered via Docker containers. SageMaker mandates that everything runs on a Docker container. So the LLM has responded. So immediate steps to take: monitor your symptoms, stay hydrated, rest, over-the-counter medication, go into sick medication. So basically, the LLM has returned detailed analysis of what should we do when we have fever and aches, and conclusion. And we'll also provide a conclusion. Fever and body aches are common symptoms that can be caused by the variety of illness, right? So yada, yada, yada. So basically, you can basically what I'm saying is the LLM is responding, right, on the SageMaker environment. So next, I'm going to ask another prompt. This was our chat completion API, by the way, where you have the messages format, right? These are the new or the standard ones nowadays, right? Previously, we also have support for the text completion API, where you just pass the prompt directly. So I have asked here a question based on the description: on 20-year-old pregnant woman at 20 years gestation presentation. She states the 1-day cycle. She is notable and characterizes. So what is the following best treatment for this patient? I'm asking based on this, right? So, and these are the options the LLM has to work with, right? Okay, the endpoint has responded and it has answered. Therefore, the best treatment for this patient is nitroglycerin, right? So it's taking this context. The patient is a 20-year-old pregnant at 20 years gestation presentation. So the best treatment for the UTI pregnancy is nitroglycerin. So it's providing an explanation as well, and it's saying that the best answer is nitroglycerin, which seems correct. Okay, next is the vision capabilities of the model. So this is an online vision, meaning the LLM is going to see what's on this URL, right, and respond with and answer the question, what does panel illustrate? So let's first see what the image is, right? So I'm not from a medical background, so I might not have all the knowledge of what this diagram is showing, but I can see this is an MRI diagram of the brain, right? So to call this image to be processed by the vision capabilities of the model, you're going to use this type of format on a chat completion format, right? So you just need to pass the content, you need to pass the image URL, and image URL can be the link to the image, right? So you can pass this as an image, everything is still the same, and you can invoke the endpoint. So we have asked the question, what does panel D say? So in this panel, right? Okay, so the LLM is thinking at the moment. It's the request is going in and it's going to respond back. So understanding the image panel, the provided image consists of 4 panels. So it has, so the LLM is now able to see what's on this image, right, on this PNG image, and it's able to describe what each panel is doing, skimming down the penalizing of speech reason. Panel D label 8 weeks of follow-up. So yeah, this is the 8-week follow-up of the brain. As panel diagram 8 weeks after the initial admission. This image likely represents the chronic phase of the infarct. I don't know what this is, but okay, basically the LLM is able to see what's on the image and it's able to process it and give response. Another way you can send the image to the model is via using base 64 encoded string, right? In case you want the endpoint to be running on a secure environment, you have network isolation in place. So what you would probably do is you have the image on your machine and you convert it to a base 64 encoded string, right? Okay, so this is, I think, a microscope picture of a tissue, and we are going to send this image to image to the LLM to process, right? So we're asking the question, what does this image D show? Right? So image D was showing, and as you see, to call the response, we have converted this image to a basic string, and we are passing the same thing, image URL, but instead of the URL that we sent before directly as the HTTP request, we are sending the basic string, which is compatible with OpenAI schema as well. So this also will be processed by the LLM, and then response will be returned, right? Okay, analysis of image, the visually clear image, the appears to be a histological section viewed under a microscope. Comparison option based on the option image is most likely the microcystic glands of the uterus. The glandular structures with luminous spaces and the specific labeling supports this identification. So yes, 2 ways you can send your images to be processed by our LLMs. One is via the image URL format, where you can send a publicly accessible resource, right? Another, it would be to convert it to its basic encoded string representation and send it to the endpoint to be processed, right? The SageMaker endpoints also support streaming responses. They have a function called invoke endpoint with response stream. Here, everything gets responded back with streaming input. This could be helpful if you want to build some chatbot-like scenario where you don't want the response to be right away, but on a streaming basis, right? So it's the same mechanism here. I'm just going to show one of them. So we are just consuming the same prompt, same everything that we did before, but instead of we are sending an additional parameter called stream equals to true, which will provide the response on a streaming basis, right? So, and this is provided natively by SageMaker endpoints. Okay, all those things are the same thing here. It's the same image. You can further again the vision capability. You can have streaming response with stream equals to true. This would also work. Let's see one of them. So yeah, same response, but on a streaming response. So response returned by the this function invoke endpoint with response stream is a partial response where you have partial data and you could use that to create your streaming response. Okay. This section, if you are done with your endpoint, you could delete them, right, to free up your instance type that has been used. Everything is else. Batch transform jobs we aren't going to discuss because we might run out of time. But this is useful, as I said, when you have a lot of data you want to store on your S3 bucket and just have the LLM run through it, right? And you just create a model transformer job here, and it gets processed, and the output will be stored on the S3 bucket. Right? So that's about it for the SageMaker side. We'll move on to the next slide here about Snowflake. Similar to AWS, we have a lot of listings on the Snowflake marketplace. Currently, we have around 40 plus endpoints available on the Snowflake marketplace, and we are still trying to catch up with AWS stuff. We have Medical LMs there ranging from 7B to 70B. We have the identification in 8 languages, models that support that, endpoints that are available on Snowflake currently support that. We also have endpoints for entity extraction, relation extraction, assertion detection. Similar to AWS, you don't require a JSL license there. Everything happens to the Snowflake marketplace, right? You don't need to write any code to deploy the endpoints there as well. Everything runs on your Snowflake compute pool, right? A Snowflake compute pool is similar to a Kubernetes cluster or a EC2 instance, right? Which is just the infrastructure to host your Snowflake containers. So everything in Snowflake runs via Docker containers, right? The Docker container contains the model for interacting with the model, right? So basically you have an endpoint there running that takes your input, processes it against the model, and returns the output, right? And in Snowflake, what we have done is we have created user-defined functions which directly interact with the endpoint. So basically there is an SQL statement or SQL function available to you that will let you interact with the model. And this is very helpful when you have data on Snowflake and you just want to process it against the endpoint, right? And you just write a simple SQL query and it takes care of it, right? And in Snowflake, there is a flexibility in terms of compute pool. So in compute pool, there is a mechanism to set the number of nodes you want. There's also auto scaling mechanisms, right? It's fairly new, but fairly robust at this point. So all these functionalities are provided out of the box, right? In Snowflake specifically, we also added Streamlit apps because it's supported, and it's a good way to show you the capabilities of the endpoints, right? So basically, I'll show you in a bit the Streamlit app. What it does is you can use to interact with the endpoint, right? I'll show you in a bit the demo, right? And this is powered via Snowflake native apps. Sorry, the native apps is a technology which lets you combine all these Snowflake container services, creating Streamlit apps, and provide you from an apps perspective in the Snowflake ecosystem. Right. So let's see how we can deploy a Snowflake endpoint, right, that we host. So let's look at the Snowflake marketplace. Okay, so if you need to be logged into your Snowflake account to get the subscription process going. So on the Snowflake marketplace, after you click the link, we can see all the listings that are available. For the Snowflake marketplace, I'm going to try to deploy the clinical de-identification model just to move a little bit from the LLMs. The de-identification is one of the name entity recognition tasks that requires to be fairly accurate, right? Because you cannot make some mistakes on PHI entities, on de-identifying PHI entities. Using LLM, you can get around 85 to 90% accuracy, but for clinical de-identification tasks, it's generally preferable to have around 95% or more accuracy, right? And since our clinical de-identification model was trained specifically for that purpose, it's much more accurate than general purpose LLMs or medical LLMs at this point, right? So to get started on the subscription process on Snowflake, you just click on the listing and you'll have access to the pricing information or the you see pricing options, right? Since I have already subscribed to the product, I am saying an expired product, but basically you will have a get button here that allows you to fill out your information. You also have trial option, as I mentioned, since my trial already expired. And Since my trial has already expired, showing expired button, but you will be able to use the model on a trial basis, right? And you just click on the get instance access button, then an app would be installed on your account, and the app will be visible via the which one? Okay, monitoring marketplace catalog. Yeah, on the catalog and apps, right? If you click on catalog/apps, all the installed apps will be visible there. Now, going to the app sections, you can see I have already pre-installed and clinical identification app. So if I go here and check, this is how the app would look like, right? Basically, you have a Streamlit app that is running. You have the option to start and stop an endpoint, right? So this is the control mechanism to start the endpoint. So you have the number of instances that you would like to perform the operation on, or how many endpoints would be active for your inference, right? So if you have lots of requests, you can spin up more instances. But to get the Docker container started, you can click on the Start Service button, right? And this will essentially start the Docker containers on the background, right? And this app will refresh. So you can see now the service is starting. Because it's a Docker container, it does take some few minutes to get the services up and running, because there are models on different repository, and everything. The model needs some time to get the services. The model needs some time to load up. That's why it will take some time, around 4 to 5 minutes for the containers to start. And once the service starts, the UI will change. It will look. Okay. Now the app has started. This is the UI. Basically, you have the option to use the UI or the Streamlit app to perform your identification operations, or you can use SQL as well here. Basically, the SQL app, I'll show you in a bit. So what SQL functionalities we have as well. But in order to call the UI, just you can click on the apply button here. So this is the default masking policy, which is mask, and these are just the input text. So if you want to play around with what the model does, you can perform these operations as well on the UI, right? So since it's a masking policy, it's able to, it's identifying the PSI information and is masking it, right? You also have the option to obfuscate it as well, right? It does basically the same, it performs the same de-identification operation, but now it's going to obfuscate the PSI entities, right? So let's look at how the SQL operation works, right? This UI is good to test the model, to check the output. Now, if you want to perform some real operations, you probably use SQL, right? To use the SQL, you will just open a worksheet, a Snowflake worksheet, right? So I'm going to have a worksheet ready, or I could use a notebook as well. So let's see, let me use a notebook here. So I have a demonstration notebook. Basically, the notebook is doing the same thing as the worksheet would do, right? So these are all the functionality that you see on the UI are powered via SQL functions or SQL call procedures. So we have a startup functionality, which does the same thing when you click on the start service button, right? It just starts the Docker containers and make sure everything is working. So for the masking policy, right? So the marks operation, you would use a function like this, where you just put the catalog name as the app name itself. So clinical identification demo app is the name of the app, or a database or catalog, you would say, and app public is the schema. And prediction UDF is the function that has been provided by us to call the endpoint, right? So if I run this function, what it does is it runs the same, it invokes the endpoint, right? As I mentioned before, everything is powered via Snowflake container services. We have a container running on the background, right? And this operation UDF function is calling the endpoint, right? So you see, we send the input as a parameter here, record, right? And it's masking the operation. So the output is masking the operations, right? Masking the input and returning the output. So this is how it would work, right? By default, mask is the default masking policy. You could also choose to use obfuscated, which can be sent via the second parameter. So the first input parameter is the text you want to have obfuscated or de-identified, and the second parameter is the masking policy, whether you want it masked or obfuscated. Right? So if I run this, right, it performs the same operation, but instead of now masking, you get the obfuscated parameter. So everything is randomized. The record that the PHI entities are randomized, right? Now, the beauty of this SQL approach is, let's say you have a lot of data on your Snowflake database, right? So, for example, here I have around 100 or so ticks, I think, right, of synthetic PHI entities or PHI data, right? Let's say I want to run it against the endpoint. So, what you would do is, if you are familiar with SQL, since this is a user-defined function, you can just pass your column, which is the text column here, right, through the function. So if you do something like this, what it will do is it will run all the inputs you have through the endpoint on a batched way, right? This functionality is provided by Snowflake Container Services, right? And you would get the results for each of your entities, each of your inputs via the same UDF, right? So I'm just going to do a limit of 5 because it might take some time, 2 to 3 minutes for around 100 records to be processed, maybe less than that. But for saving time, I'm just going to run it against 5 documents, right? So what it does is it takes the 5 documents, it will send batch requests to the endpoints, right, based on the documents itself. And once the results are ready, it will aggregate the results and to provide you the output, right? So okay, so basically I got the response for each limit, right? So if I want to then see the side-by-side comparison, I could do something like this. So I have the text sent in, and I want the de-identified text as well. Basically, it will run the same thing again the panel, but now you have the ability to see both the results at the same time. Okay, you see the patient case, since we tried to use the mask policy, it's identified the hospital, everything. So the identification is done on Snowflake environment. You want to use the identification like this, right? Another functionality that we provide through the SQL APIs is the stop app call procedure. Basically, if you are done using the service, you probably want to stop your services to save up on your compute pool price, right? So in order to do that, you just click on the stop app or click on run this procedure. If you want to use program it in a programmatic way, you just call the service and all your sorry, I'm on a different app, sorry, topic, and you just call stop app, and it will stop the services and free up your compute pool. So this covers the Snowflake section. Now let's move on to the next topic, which is Azure Marketplace. Currently, we have more than 5 LLMs available on the Azure Marketplace. They range from 7B to 70B. Medical LM Medium is the 70B one, and it's available on both Snowflake and Databricks as well. Similar to those marketplaces, you also don't require a JSL license to have the endpoint running on Azure Marketplace. It's a no-code deployment. With a few clicks of the button, you can have the endpoint running on your Azure infrastructure. I'll guide you through this next. So let's see the link. Click on the link and see what models are available. So we have Medical LM 8B, Medium, 32B, right? So I'm going to deploy the Medical LM 14B. So to do this, just click on this free trial button here. You need to be logged into your Azure account to do this, right? So just click on Get It Now. Okay, it shows the basic information. Click on Get It Now to get the portal started, the Azure portal started. Once this page is loaded, just click on the Create button. This will go. This will open up a form which lets you create a virtual machine with the required infrastructure, right? So fill up this form with the machines that you require. It's 14 VM. Okay, so I'm going to use a GPU instance. Okay, West US. I'll use this one. I don't want infrastructure. This machine is fine. And I am going to use the SSS key. This is as per your requirement. You don't need to do it, obviously, but if you need, you can do it as well. With this, I'm going to click on the review and create person button. I'll ignore this. And on Azure also, the VM is on the endpoint are on a per hour pricing policy. So you need to be aware of the pricing. If you are done with the endpoint, you can close it right by terminating the VM instance. So let me show you how you can interact with the endpoint here. To do that, just click on the create button so that the VM gets provisioned, right? Similar to the other marketplaces, it does take few minutes for the endpoints and the machines to be started. Azure needs to allocate the resources, get the VMs, and deploy our images there, right? So we don't need to wait a few minutes for the deployment to complete. Azure will redirect to this now in progress page. So once the deployment is in progress, and once it completes, this page will refresh automatically to completion page as well, which we'll see. As you see, as the deployment has completed, this page changes automatically. Now just click on the go to resource button, which navigates you back to your VM instance. You have a public IP available, which lets you interact with the model. Even though the machine is now running, it's still working to get our models there and loaded. So let's wait for a few minutes and I will show you how you can interact with the model on Azure endpoints. Once the VM machine is provisioned and the endpoints are running, you should be able to access the documentation of the page from this URL by controlling the docs parameter on the URL. So this shows you what endpoints what endpoints are available on the VM machine. So to test this, I'm going to use the Jupyter notebook or a Google Colab notebook. Server URL, I'm going to copy it from this instance, right? And I'm going to perform some medical LLM operations on the model, right? So to do this, you can just import JSON request. So this is totally OpenAI compatible, right? Similar to the ones we had on AWS SageMaker. So I'm just creating a prompt, a few prompts here. I'm also putting a system prompt so that it's able to think. I'm also asking it to, I'm also asking the LLM to give me reasoning steps, right? So I have a keyword here called think, and I'm asking it to provide some reasoning steps, right? So for the first prompt, I have asked how to do emerging mRNA technology compared to traditional vaccine approaches for disease prevention, right? So to interact with the model, I have created a helper function called get completion response. It just takes a URL and a payload, and if it has a 200 status code response back, we just pass the data and show it, right? So this is the chat completions format. You see in the URL, we have added v1/chat/completion, which is the OpenAI compatible route. And we also use the proper payload here. That is also OpenAI compatible with the chat completion response. So I'm going to call this endpoint, right? With the data for explaining about the why emerging mRNA technologies compared to traditional vaccine approaches for disease prevention, right? So we got the response here. Based on the prompt, it also gave us some thinking reasoning steps, right? It has deduced why it's thinking, and it's given final advantage as well, right? Next is the text completion route. See the URL had changed here. Instead of v1/chat/completions, we are using v1 completions. And we provide a prompt instead of the messages, right? This is the text completion format, right? I think we asked the closed question here based on the prompt, right? So based on this, it gave a thinking step because we asked the prompt to do that, and it gave an answer because B is it gave an answer B, right? UV is specific indoor nucleus based on the prompt that was provided. Next are the streaming responses. Streaming responses are very similar. You just need to pass stream equals to true when you make a post request to the URL, right? The stream is available on both the chat and text completions API. You just need to provide stream equals to true, and you'll have streaming responses. Good for building a chatbot application with this, right? Similarly, for the text completion, you have the same mechanism, just pass stream equals to true to the v1/completions route, and you'll get the responses in a streaming way, right? This covers the Azure deployment of endpoints for our LLMs. The process is quite simple, as you saw. You just subscribe to the product, create a VM out of the subscription. Once the endpoint and the models are loaded, you can use OpenAI compatible routes with the server IP and make requests to the endpoint. Now, moving on to the next topic, which is on-premise deployment of the medical JSL LLMs. For on-premise deployment, you do require a universal license to get it deployed. The endpoints are totally OpenAI compatible, and you can see here the LLMs that are supported for on-premise deployment, right? I might not be able to show you how you can use it because of time constraint, but the basic gist of it is that you just pull a Docker image. We have inference image that you can pull, and you just run a one-line command with the license that is required and model ID, right? So with this, you can launch an endpoint on your environment, provided you have enough GPU to support the model. Right? We also have clearly documented section on the website itself. Here it explains basically the same thing, where you pull the image, you run a one-line command with license and the model ID parameter. So this table shows all the LLMs that are supported, the recommended memory given if you want to load the full context length. It also has some memory optimization tips and how you can call the endpoint, right? Yes, so this is how you can deploy an endpoint on-premise environment. This concludes all the demo section of this session. Next on this slide, I have added a web page or links to documentation where you can get started to explore with our marketplace products. We have a free trial for all of our listings. You can just subscribe and run the models on your preferred cloud provider. You can click on these links and explore. If you have any questions, you can email me at ht's@johnsonlabs.com. Thank you for taking this session. Have a wonderful day. Bye.
All right, we'll take 5 minutes break again before our next session with our head of product, Dia.
Hello, everyone. I'm Dia Trâmbițaș, the head of product at Johnson Labs, and I will be continuing the training session today with an intro into the Human in the Loop Generative AI Lab, which is our no-code platform designed to accelerate AI model development while keeping human annotators and human experts involved in the process. The goal of this training is to help you understand how to design, how to run and optimize your AI projects using the entire Johnson Labs ecosystem. That means everything from data annotation, the identification, LLM response comparison, compliance issues, how to integrate the tool via API into your existing workflows. So I'm going to take a practical approach today, so I hope that by the end of the session, you'll not only understand the features which are available as part of the Generative AI Lab, so like you'll not only have a conceptual understanding of the tool, but you will also have seen the tool in action and understand how to play with it. And after the demo, you'll also get access to an environment, an instance of the Generative AI Lab to be able to practice everything that you've seen during the training on your own, and then make use of that information for your practical use cases. So let's quickly walk through the structure of today's training. I'm going to start with a short presentation of the Human in the Loop workflow that is offered by Generative AI Lab. I try to cover the concept, the workflow stages, all the tools which are available. I'll give you some best practices on how to integrate the human feedback into the AI development. Then we'll explore the resources and tools which are available as part of this platform. Where you will see how to manage all the models, prompts, and rules, and include those into your own project. We'll see some specific projects for specific use cases, for instance, for the identification. Then we'll take a short break, and then we'll deep dive into PDF annotation. We'll see how we can reuse models which have been trained for text processing for PDF pre-annotation, but we'll also be able to check a little bit how to use visual NLP specific models to annotate those PDFs and maybe to train them if necessary. Then we'll move to LLM evaluation and LLM comparison type of projects, and I'll show you how to create those projects, how to import prompts, how to generate responses using different LLM endpoints, and then how to set up projects to allow you to assess the outputs of those LLMs. We'll also cover the audit dashboards, which are offered as part of the Generative AI Lab platform, which allows you to track all the actions of your users and to ensure that the project is compliant with the current regulations. Finally, we'll wrap up with an API integration and show you how to interact programmatically with the Generative AI Lab from within your data processing workflows. So after the training, you'll receive an email with credentials that will allow you to connect to this demo instance. This is the URL where you'll be able to access Generative AI Lab. So please check your inbox, and if you don't see it there, make sure that you'll also check the spam folder, and if you did not receive it in the spam folder as well, write us a message and we'll make sure that you have the right credentials to connect. So this instance will remain available for the next 2 weeks, so you'll have time to explore and play with all the features and experiment them with your own data. You'll have a couple of example projects on GitHub. You have the link here. You can download those projects. Those are zip archives containing all necessary project files for a correct import in GenAI Lab. So just make sure to remove the TXT extension from the file name, unzip the archives, and then import the zip file, the resources into the Generative AI Lab. If you need additional, resources, or if you have want to deep dive into the different features of the application, I've also added here a link to the documentation, and there is some documentation available also as part of the Generative AI Lab application. So let's start with a short intro on data curation and why is it crucial for and why data annotation is actually crucial for natural language processing and for structured data extraction from unstructured text. So at its core, annotation transforms the unstructured text into structured data, something that machines can actually understand and learn from. It provides what we call ground truth, the labeled examples that model rely on for training and for validation of the results. Without those accurate annotations, even the most sophisticated algorithms will actually fail to generalize well and to produce the right outputs given the prompts or the test data. So annotation directly enhances model performance by ensuring that the models understand language in context, whether that's sentiment on entities or intent on the relationships between words and so on. Essentially, annotation is how we are able to transfer the human knowledge and intuition and experience into a machine-readable form that can be exploited by the AI models. A very important takeaway here is that the models are only as good as the data they are trained on. So poor quality annotation inevitably leads to poor quality models. So having said that, it's very important to understand that you cannot just annotate data using different tools like Excel, because we've seen many of our customers using text editing tools to create those annotations and then to transcribe those to different computer formats like JSON or CoNLL, just to prepare data for training. This is, it's a solution, but it's a very tedious solution, which usually does not yield very good results. In general, what we advise is that in order to generate high quality annotation, you should use annotation tools. There are many on the market, and those tools, what they offer on top of what you can simulate via Excel or via Word documents or text documents and different types of improvised annotation, is that they offer a systematic and organized workflow for this data labeling task, and they usually support a better collaboration between multiple annotators and multiple domain experts that will annotate those documents, and then that will try to transfer their knowledge into annotations. So those tools, those annotation tools, should enforce some level of standardization and consistency among the different people in the team, different annotators, and ensure that everyone follows the same rules or the same schema and the same schema of your taxonomy. What annotation tools also should, or the majority of them do, but this is very important, they should include built-in quality control and review mechanisms to help the annotation team maintain accuracy and catch inconsistencies early on. Also, they provide or they integrate automation and AI-assisted features, such as, for instance, model-assisted labeling or active learning, which really accelerates the annotation speed while maintaining, high-quality annotation, right? So you should never start from scratch, but you should try to automate the annotation so that the work of your human experts is minimized as much as possible. So there are, as I said before, many annotation tools on the market, and here are some elements to consider when selecting the tool for your team. Those are the three main pillars to consider. First of all is high productivity. So the tool you choose should keep annotators in the zone, should be very intuitive and easy to learn. It should offer ways to speed up the annotation process, such as keyboard shortcuts, minimized number of clicks, and a minimized number of eye movements that should be required while your team is working on generating the annotations. Or different other improvements in workflow, such as, for instance, transition between documents. Second is teamwork. So good tools support multi-user projects with role-based permissions for different tasks based on their need-to-know basis. They should also support customizable workflows where you can integrate validation, review, model training, and so on. Not all projects are the same. Not all of them follow the same rules, and therefore they don't have the same needs. So you should be able to customize the workflows to your specific use case so that you optimize the work of your team and the load of the team. And third, the tool that you will choose should be able to improve over time, right? So it's not a very good idea to pick a tool for which the development stops, because there are many new LLMs out there, new solutions that you'll probably need to integrate in order to optimize the work of your team. So you should maybe focus on a tool which is continuously developed and improved, which is able to adapt itself to the feedback that the annotators provide as in the form of annotations and of corrections. Yeah, so one other important feature that the annotation tool should include is the ability to automatically improve the predictions over time. Like, for instance, your team is annotating a certain number of documents or is correcting or reviewing pre-annotations for a certain number of documents, and then new documents come in. So at that point, all the knowledge which was already transferred from the annotation team should be taken into consideration so that the new documents which will be annotated will include this feedback, and the predictions will be better or of higher quality. Okay, so those are the main requirements. Now that we've set the stage, what is annotation, the fact that there are out there tools for a team to use collaboratively to generate ground truth annotation and to structure data. Let's see how Johnson Labs solution looks like, and let me show you. I just want to make sure that you can still see my screen. Okay, so yeah, this is the landing page of the Generative AI Lab. So once you access, you'll get credentials for this application. You can access it via your regular browser at this address. Once you log in, you'll see this type of dashboard. So here is the project view, right? So you'll see a list of projects which are already defined on the environment and for which you have been added as a team member, or projects that are created by your user. So this is the main page. We have a hub of resources and then a set of tools and settings that you can use for putting together your project. So as the dashboard gets pretty crowded sometimes, because you can expect that if you have a larger team of annotators, they will work on different projects in parallel. We have different filtering options here, sorting options, and grouping options to be able to navigate between the list of projects. Now let's start with an example of oncological data. So this is a project I've already set up so that we can quickly understand how Generative AI Lab works and what are the features that it supports. So once you click on the project name, you get redirected to the main tasks view, where you see all the documents which have been added to this project. So you can see here I have 5 different oncology nodes. If you click on one of them, you see that, okay, in the upper side of the screen, there is the taxonomy, so the list of entities that I want to extract from this patient node. Here you see a synthetic patient node that I have prepared for and uploaded into this project. You see that there is no annotation on top of the project, on top of this text or this task. And on the right side, you see a panel with the status of the current task, right? So you see that there is no annotation defined, no version created, so only the default version created for the logged in user. So I'm currently logged in with the admin user. Here you can see what is my role for the project, and I can switch between roles that are available to my user at any time. Okay, so we'll dive deeper into all of those details a little bit later. For the moment, let's see how we can not start from scratch. So I don't want my team of annotators to come in and start reading all of these text and then using the entities in my taxonomy to annotate all of those, all of this content, right? So I want to speed it up. And for that, I have this button, which is called pre-annotate. If I click the button, according to the project configuration that I choose, I see here all the elements that I can use to pre-annotate my data, right? So I see that I have a couple of models available. You are already familiar with those models. Those are Johnson Labs models, which are published as part of the healthcare library, which was already presented by Basil and by Kshitij earlier, right? So I have added all of those models to my project configuration, and now I want to reuse them for those new tasks and see what they pre-annotate, what type of annotations they automatically generate. After that, I'm going to assign those tasks to my team of annotators and ask them to simply correct the predictions generated with my models. So as you can see, currently the pre-annotation is running for the 5 tasks. My models were already deployed. And here you see the yellow circle next to each one of the tasks. Once the pre-annotation is done for those tasks, it will turn green. At that point, I can click on my task and see everything with all the information which was identified as part of this task. So you can see that we have entities here, we have relations between entities, and we even have ICD-10 codes, right? So those are oncological nodes, so which present or describe patients with cancer, and we are able to resolve all the cancer diagnosis to ICD-10 codes, right? Now, the task of my annotators will be to just go through those pre-annotations and correct them. So now on the right side of the screen, you can see all the entities which were discovered, the relations as well. We can hide them if it will be easier to view the extracted entities. We can show them. And then when I do mouse over each one of those relations, they will be highlighted as part of the main screen, main annotation screen. And this will make the validation process or the feedback, the human feedback, easier. Okay, still I see in the version panel, I have one completion which is in progress and predictions which are generated by the Spark NLP pre-annotation pipeline, which were just created. Below you can see a filter which allows you to remove from those pre-annotations automatically generated by the model, those which are below a certain confidence score, right? So if you simply move the slider to the right, you'll only the only annotations which will remain on the on your completions are the ones which are between, for instance, 0.4 and 1 in terms of confidence score, right? Now let's go back to the tasks view, and here, okay, we see that all my tasks are now pre-annotated. Let me assign them to some annotator. I'm gonna assign them to user Dia as an annotator, and I'm gonna assign some of them to a reviewer, one. Okay. Now, if I log in into the tool with a different user, right? Same tool, but a different user who has a different role. So Wana, who is reviewer, she will only see this project because she was only added to this oncological data curation project. If she clicks on it, she will see that she needs to review 3 tasks, but they are currently incomplete, so she doesn't have any work to do yet. If I log in with the user Dia, who is an annotator, I see the projects which are assigned or where Dia is part of the team. And for the oncological data curation, oh, sorry, let me connect again. So for the oncological data curation, I see task 2, 3, and 4, where this user was added as an annotator. Now, on the right side, so next to the, in the tasks view, on the right side, you can see different filters as well, which will help users pick the next task to work on different, based on different criteria. So first of all, you can see that all those tasks added to the project will go through a series of statuses. At the beginning, they are incomplete, right, as they are now. When the annotator assigned to them starts working on the task, they will switch status and will go to in progress. When the annotator is done and they have submitted a ground truth completion, they will go to status submitted. When they are submitted, they will become available to the reviewers to review, and the reviewer can accept the corrections or the annotations from the annotators, or they can send them back, and then the task will go to status to correct. Okay, so now if I click on the first task, the annotation screen will open. Okay, I can start by filtering maybe the low confidence score predictions and say, okay, I'm going to start from this and then edit this version of pre-annotation. This will add a new completion, right, which was generated by Dia, and we'll see a lot of a couple of statistical information here, how much time each edit will take, how many, what's the source, if this completion was cloned from something else. You see here it was cloned from a prediction, which was filtered using this information. All of those completions, they don't go away, so they are not, users will not be able to remove them. So we'll have an audit trail of everything that happened in terms of annotations for each one of the tasks, for each one of the projects, right? So, and we'll be able to go back to that version and edit it further or clone it or just check it and compare it with another completion. Now let's assume that this is correct. I'm just going to update it. If I want, I can do some modification. For instance, I don't know, let me go to the annotations view and pick these relations and just remove it by pressing the back button from my keyword, right? From my keyboard. I can also add new annotations very easily. I just select the entity from the taxonomy, and then I select a chunk of text, and this will add my entity to the list of regions that I have annotated. I can update this, and this will save all the edits that I did to this current completion, or I can submit it. And when I submit it, it's no longer editable. If I submit it as ground truth, this star will be activated next to my completion, and it will be taken into account as the final version of my work and as a ground truth completion for the training process in case I want to tune this model with the feedback from the annotators and have an improved version of my model. Finally, here I have my overall progress. I see that I have 3 tasks assigned to me, and I have submitted 1. Now, going back to the tasks view, I see that, okay, this task has changed its status. I have two more to go. Maybe one interesting thing to go over is the fact that we have here, as I said, for the cancer entities, I have added entity resolution codes, which are generated also by a model. And let me change here the view. So I am now able to group all of the entities by their name, entity name. For cancer diagnosis, for instance, here I have prostate adenocarcinoma, and here if I have information about the code, ICD-0 code, and the description, maybe, yeah, the description of the code. I'm also able to remove those information if they are not correct, and then search within the ICD-0 taxonomy for another code by you just typing in the name of the chunk that I want to identify. Okay, so now, for instance, if I update this, we'll see that I have tasks, different tasks in different statuses. Now, if we go and see the same project as a reviewer, let me just quickly refresh. What will the reviewer view? So he will see that, okay, there is one task which was already finished by the annotator. And here he will have an option to add the review. He can either approve it or request changes. And here add a comment, for instance, check again the cancer diagnosis. Submit review. Okay, now in the tasks, okay, this particular task which was rejected by the reviewer will go back to in progress, and it will appear into the annotator queue again with the status to correct. Okay, so this is how the workflow is set up. Let me go back to my main project. Okay. Okay, so we have the tasks. We have the annotators which started working on the different tasks. There are also other productivity tools that you can use. You can tag your tasks, for instance, assign different tags to them. For instance, if you want to train your a new model or to fine-tune the model, you can select certain tasks for the training and certain tasks for the testing of the model so that your experiments are reproducible. As a manager, I will have access to all of the annotators' completions and also to the reviewer. And as you've seen before, I'm able to assign one or more annotators and reviewers for each one of those tasks. Okay, so let's see how is it possible to get to this point. Okay, so here you've seen that by just importing some text files, we were able to extract a lot of structured data out of this unstructured text, but just with a click of a button, right? Now, how do we set up this type of project? So in the dashboard page, you have this new project option. If you click it, you are redirected to the new project page. And here, let's create a new project which will annotate forum posts, right, written by patients, right? So we'll just put in a title for the project. We'll select how we want the tasks to be served to the annotators in sequential order or randomly, according to the assignment. Usually it's good practice to add a description for your project so that you'll be able to correctly identify it in case you are participating in many projects and you have a lot of very crowded dashboard. And also here you can add project instructions or annotation guidelines. Those are important for your annotation team so that they are able to align their work and the way they annotate based on those instructions. I can tell you more about those at a later time, but for the moment, let's just set up the project. The next step is to add team members to your project. So here you can start by searching within your list of existing users, and then you select a user, and then you pick the role that you want to assign to that particular user. And you have different options here, annotators. Then you can add other team members, reviewers, right? And let's see. And they will have access, so the annotators and the reviewers will only have access to the specific tasks they have been assigned to. The managers will be able to see all the tasks and then also change assignment. Now, as you can see here, those users have a defined priority, and this priority is important when there are multiple completions for one task, which are labeled as ground truths, but they are ground truths for different annotators. Based on this priority, the model training will pick which completion to use for each one of the tasks, right? So the smaller the priority, so the higher the user is in this hierarchy, more important his completion and or his review will be. So for instance, it makes sense that the reviewer is maybe the highest in the hierarchy, so that the completions which are generated by the reviewer or validated by the reviewer are picked for the model training. So once you have set up your team, let's go here and then let's pick a name entity recognition project. Okay, so this will change the configuration behind the scene, and you'll be able to preview how the project would look like on the right side of the screen. There seems to be a glitch here. Let me refresh maybe. Okay. Okay, so here you see a preview, a default configuration for this project. Let's move on. We have added this option to allow users to select which part of the documents they want to annotate in case you want to run pre-annotation using LLMs. So you don't have to pre-annotate large documents entirely, but you can define relevant sections. But let's just annotate everything for this example. And okay, so here on step 3, you are able to select the resources that you want to add to your project. And we have different types of resources, models, rules, and prompts, which are available and you can check under the hub of resources. Let me just briefly go here. So under this hub of resources, you can see all the online models which are compatible with the Generative AI Lab. So you have seen both Basil and Kshittis have shown you the NLP Models Hub. So models available on the NLP Models Hub can be automatically pulled from GenAI Lab. You can search for the models using different keywords like oncology. You see all the models which contain this string, right? And you can select, you know, among all of those. Now they have a short description or some metadata available here. And some of them have also benchmarking information. Yeah, if you click on this, okay, not this one, but let's say NAR DSL, which is one of our most comprehensive, okay, models. You see, when clicking on this small icon, you see benchmarking information, F1 score for all the entities which are predicted by this model. And you can simply select it and download it. This will copy the model to your instance of GenAI Lab. Now, in this local models page, you see all the models that you have downloaded from NLP Models Hub or that you have trained using the GenAI Lab tool, or you can also upload your models. The only restriction here, you can see this model was trained. You can download the training logs. You can see the benchmarking information. Or as I said, you can upload your models if you have trained them on Databricks or if you train them via Python notebooks. The same for embeddings and the same idea. Those are all the embeddings which have been downloaded to this instance. Then you have the pre-annotation resources. We have support for rules, and here we support the definition of 2 types of rules: regex-based rules and dictionary-based rules. I have defined here a simple one, which is extracting age for patients based on regex, and then I've defined some prefixes and suffixes. You can add as many rules as you want and then reuse them across your projects. You can also import the rules and export them if you want to move them between different instances of the GenAI Lab. In terms of prompts, we support 2 types of prompts: zero-shot prompt and external LLM prompts. For external LLM prompts, we have different LLMs endpoints that we can integrate with, and the prompt that we can use for running the prompt in order to extract entities or to classify different parts of documents, right? So here, for instance, I have a prompt which is identifying problem entities. So this is the actual prompt. It's very similar to what you are probably writing with ChatGPT or Claude or other Grok or other LLMs. What you can do is paste here text and then check what are the outcomes. Let's see if I have an example here. never mind. We'll find. We'll see how the prompt works inside of the project. So as I said, we have two types of prompts for NER and for classification. I've added here two examples. Those will be available for you when you get access to the instance. This is how the classification prompt looks like. You just have the instructions, and then you have the classes, present or absent in this case. I want to classify if the provided text contains or is explaining an adverse drug event which was observed by a patient during the administration of this treatment. Now, the reason why I have created those two prompts is because they are both relevant for the use case that I want to show. So I want to identify the problems which are mentioned by patients via different forum posts, and then classify those posts to see if they contain adverse event mentions or not. I will also use this rule, and then I'll also use an NER model, right? So going back to the project definition, here in the Use Resources tab, I can simply specify, okay, I want to use say treatment and test from this model. Okay, so I have here the list of all models which are available on my local models hub. Okay, I save the configuration, yes. I see here that I also still have in my taxonomy the default entities, right, from NER on to 100. I'm just gonna remove those and keep just the treatment and the test. I'm saving my configuration, and then move next to the rules tab. Here I have one rule. I'm gonna add it to my taxonomy. It will appear here. Save my configuration. And for the prompts, I have two prompts, right, which are both external. This one is using Azure OpenAI integration, and this one is using GPT, so the regular OpenAI integration. Now, if I select those two prompts, I get a notification that this will associate my integration with this project, okay? And I click OK. I do the same for this one, okay? Now, the reason why this notification appears is that, as you know, the API calls to LLM, they are all paid calls, right? Now, usually if you have this type of integrations, you want some admin users to be able to manage them so that your costs don't go up the roof, right? So this is why we have under settings, system settings, a way for the admin users to control how to associate LLM endpoints to each one of the projects. So I will see here that my those two endpoints have now been associated with voice of the patient analysis project. I can simply remove this association if it's not something that I plan for. Or something that I want to, to pay for. Let me just reload this. Okay, so my problem and adverse event. Okay, so those were added to my configuration. I save everything. Okay, and now I can go ahead and customize my labels and the way my project will look like. So I'll have here those entities that I have added from the models, prompts, and rules, and I have here the classes, the choices from my prompt. I can also see the XML version of this configuration. Here I see exactly what the models and rules and prompts, all the resources linked to my project. And here I can, edit the entities, change the colors for each one of the entity, select some, here is where I link entity resolution models I have a list of resolvers that are already downloaded, but it's not the case for this project. Or I can associate a lookup data set in case I want to do entity resolution manually. And here I can add label instructions. I'm going to show you a little bit later, because for this project it's not very important. So I save my configuration, okay, and say, okay, I'm asked if I want to deploy this configuration to be available for pre-annotation once I import the data. Say I can either only save my configuration and then do the deployment later if my server is busy, or I can just simply deploy the configuration right now. Now, if I navigate to my to another page under settings, which is called clusters, I can see here all the models, all the configurations which are currently deployed for pre-annotation. I see the oncological data curation, the first project that we visited. You see some information, what is the license used by this project, what was it used for, so pre-annotation, what's its status. You see that it's currently idle, and it was deployed a while ago. So maybe nobody is using it. I can just simply remove it to save space and then to have more efficient processing. So you've seen that now, as I've saved my configuration, my current project is being deployed. I can check the logs and see what's the status of my deployment. Now, let's go back to the project. So once I've finalized this configuration, I can go to the tasks. I have no tasks currently, so let me just import some new tasks and then pre-annotate them. So I'm just gonna okay, import. So we have different import options. One of the most popular one is JSON. I'm going to just select this JSON file with a very simple structure and import all the tasks which are included into that file. Next, I can click Explore Tasks, and I see all the tasks added here. And you see this is data from some patient forums where they explain their experience with facing different diagnoses and different problems. Now, if I go to the task view and click on the pre-annotation button, you'll see that the current configuration is already deployed. You have an option to pre-annotate all the tasks or only the incomplete tasks or only the tasks from the current page. And you see here the resources which can be used to pre-annotate. Now, if I click pre-annotate, you'll see that we can easily manage all types of resources of different genders, different types of resources, models, rules, and prompts together, and generate more data. So this is very useful, for instance, when you want to train a model for a very specific task, but you either don't have a model available, for instance, you don't find it on the NLP Models Hub, or you do find a model, but there are a couple of entities which are not covered by that particular model, and you'll need to add those entities and then tune the model to be able to cover those new entities, or you simply don't have any resource and then you want to speed up the work of your annotators and offer them some pre-annotations generated maybe by rules, because sometimes rules are good enough. Like, for instance, if you have if you want to extract medications and you have a list of drug names, or if you want to extract social security numbers or different chunks which respect certain regex patterns, right? Or if you want to use prompts, you can, or if you cannot use rules and you don't have models, you can use prompts, even if those, by pre-annotating using prompts, will be a bit more expensive, but you can do it on a sample of data or on a sample of tasks, and then train a model so that you can do it faster on at large scale, and you can do it for a lot of pages without incurring a lot of costs, as it is the case for large language models, which trying to be very expensive when used on large documents, and maybe less accurate and non-deterministic. So you see here results generated by rules, by models, and by prompts, and also classification done with with prompts. Okay. So how do you ensure that the data is high quality and that you can that the work done by your annotation team is coherent and consistent? So let me show you a couple of a more expanded or a more richer project, still based on the voice of the patient, right? So based on forum data that we have implemented with our in-house team of medical doctors. So as you see here, they've annotated more tasks. So if you go under analytics, you see that, okay, they have annotated and worked on over 4,500 tasks. You see under this analytics page, a lot of data that helps you determine the status of your project, how fast the team is progressing. You see different summaries for each one of the annotators involved in the project, the status of the tasks, who created them and when, how long are those tasks in terms of number of tokens, right? So some of them are larger, some of them are shorter, and you can then have let's say a starting point to assess the efficiency of your team, and maybe compare annotators' work, annotators between each other. So you have also additional, there is a very long list of analytics that you have here. So at annotators level, at entity level, so here you see the label frequency across completion, so how many and like how many quantities were identified across those documents, and you can see where you have a low coverage of entities. Probably the model will not do very well, so it's worth adding more examples, for instance, for race, ethnicity, or for route, for instance, for drugs. There are many examples, 600, but here, for instance, only 273. Right, so when you have low number of examples for certain entities, it's worth adding new tasks which offer coverage or more examples for those particular entities. So you see here average label frequency per completions, label frequency by annotator, variability across each one of those labels. You see, this will help you identify labels which have a lot of variety, like many examples, very different one from another, or the labels which are more or less use more or less the same chunks. Here you see the length of the label of the chunks for each one of the labels. Is in general, you should make sure that the annotation guidelines are written in such a way that the maximum number of tokens per annotated chunk is maybe 4. Above 4, it will confuse the model, and the accuracy will drop. So try to maybe divide your entities into or separate them if they usually cover more entities. Find a way to do that via annotation guidelines. Now, in the presentation, I have added a section. In the PowerPoint presentation, I have added a whole section about annotation guidelines and how our team of doctors are working. What's the process? How do you make sure that those annotations are consistent? And then this will actually ensure that the model outcomes will be excellent for your particular use case and for your particular types of documents. So you can check team productivity, inter-annotators agreement, so you can select the annotators to compare, and then you can have a lot of information about where are the contradictions, where do the annotators annotate differently one from another, and then have agreement sessions where they discuss what they have, why those disagreements appear, and then reach consensus, maybe update the annotation guidelines so that they ensure that next time those situation or similar situation appears, they will react or use the same rules in order to create the annotations. Okay. Now, once you have enough data, enough ground truth information, what you can do in order to make sure that the model is adapted to your documents and use case is to train a new model. And we have added a page dedicated for this process. I'm showing here another project for liver cancer, right? So this is another internal project we have worked on a while ago about liver cancer patients. You have here examples of presentation notes, and then a very complex taxonomy we have focused on because we wanted to extract a lot of entities, very fine-grained entities. Here we have some assertion status labels, also some relations and classification. So as you see here, we have a lot of tasks, right? So 500 tasks. But in general, best practice is to have at least 50 examples for each one of the entities or for each one of the choices in your project in order to be able to train or tune a new model. Now, even for training and for tuning models, you don't need coding skills. Everything is abstracted behind this interface. And based on your project configuration, you can select what you want to tune, the relation extraction model, the NER, or any of the classifiers that you have added to the project. Now, for instance, for training an NER model, you just select NER from the training type. You select the license here because the NER, we are dealing with medical models. You are forced to use the healthcare license, but in regular projects where you use you start from scratch or where you use open source models, you can use open source license as well, or finance or legal. We support all of them. Here you can select the embeddings that you want to use for training the model, and whether or not you want to use transfer learnings. That means that you will start from an already existing model that you want to tune for your particular documents, because as you know already, there are many models, pre-trained models out there, but if the testing data or the data that you want to use as part of your use case is different from the training data set for that model, it will not generalize well, and the results will not be very accurate. So in that case, what you can do is test the model on a sample or a couple of tasks, and then implement with your annotator team of annotators, implement corrections, and then tune that model, right? So in that case, you'll be able to include the base model labels and select, for instance, maybe I want to start from nerve oncology work in progress model, and in that case, it will include the base model labels and add the labels the extra labels that I added as part of the project, if any. Then here you can select the training parameters like the number of epochs, learning rate, and so on. You can also select how to split your training data, either randomly or using the tags that I have shown previously. You can also generate a confusion matrix, and you can apply different filters on the training data by the status. For instance, maybe you only want to use the reviewed completions to train, or the submitted ones. And then you can also filter by different tags. So once you save this, you can also activate the active learning. This will automatically train a new version of the model behind the scene, and it will deploy it for you automatically. So when you import new data, the new version will be used to pre-annotate. And then you can press the start training model. Here you are asked if you want to deploy it or not after the training, but training takes a while, so I'm not going to let it finish. Okay, so this was aborted. Here on the right side, you see the training history, right? And you can also download the training logs, right? But as you can see, there is no coding for this. So there is no coding required for you to train a new model. You're just using this very simple interface. Any domain expert can just train a new model and actually exploit all the experience and knowledge that was included into those annotations by the domain experts and try to transfer it into an AI model. Okay, so let's take a short break, 5 minutes break, and then we'll continue with another type of project for the identification, and then we'll see how to do LLM evaluation and comparison, and then how to integrate via API with the GenAI Lab product. We'll be back in 5 minutes. Okay, so let's resume. Okay, so now that we have seen how to use this tool, what are the workflows, how we can customize, how we can create a project, let's see more interesting use cases. For instance, the identification. For the identification, we have a specific template. Okay, let me create a new project. Okay, let's keep the team creation. And in the text content type, there is this template, the identification, right? So this will pre-populate my taxonomy with a list of PHI entities. Okay, I can save my configuration and move next. I want to de-identify the entire document. And in my resource reuse tab, I see that the clinical de-identification pipeline is automatically selected, and I see all the entities which are covered here. Next, I have a UI which is dedicated to de-identification. So this tab has changed compared to the other project types. And here I see all the customization that I can apply to my de-identification pipeline. So I can apply them at project level, right? So either mask all the entities with all sensitive entities with entity label, mask with characters, mask with fixed length characters. Here you see some preview. I can obfuscate them, or I can fine tune or select the identification strategies at entity level. For instance, for the account, I want to mask it with characters. For URL, mask it with entity labels. For professions, I want to just choose entity label. Let's see. For age, I want to obfuscate it into different age groups, right? So, for instance, if I have a 3-year-old, it will go into the category or into the class 4. For cities, for instance, I want to just obfuscate them or replace them with fake city names. For states, I just want to mask it with characters, and so on. So I can specify very precise the identification strategies at entity level. Okay. Okay. Once I have my configuration ready, and here you see you can define it for all the entities. For instance, for date, you can consistently shift the dates, all dates by 10 or 2 or 3, 30 or 8 days, right? So this will, for instance, change the actual date of the presentation or of the year of birth by 10 days, so that you know all the dates are shifted. If you have different encounters for the same patients, they will all be shifted with the same value, so that you can still obtain a coherent patient timeline, right? So that it doesn't randomly shift the dates or change the dates randomly, but you still and then you will lose the chain of events which happen for that patient. So in this case, you can use consistent shifting. Okay. So once you have defined all of your strategies, you can save the configuration and deploy the project for pre-annotation. Okay. Next step will be to, here you have different options which can help speed up the annotation process, like serve the next task after completion and so on. So all of those are documented on our documentation website or on the documentation page here. So if you click on this button, you'll have a detailed information in context that you can, help that you can use to help guide you in your project creation or in your work. Okay, so now going to the tasks view, let me just import some synthetic PHI data. Okay, I've created 10 nodes. Now notice that here we have a new tag, right, which is assigned to all the tasks, non-de-identified, right? So everything is incomplete, the same as in the regular projects, but we have the non-de-identified. Now for the identification type of projects, you'll see that we have two actions which are available when we want to run pre-annotation. So first of all, we need to identify the PHI entities within the documents, right? So first I press the identify PHI. Then I ask my experts, domain experts, to check the tasks with pre-annotation from the model and ensure that all PHI was correctly removed or obfuscated or masked. And after that, I will apply actual de-identification, which will remove it, and I'll remove all of those entities, and then according to my strategies, the strategies that I have defined, and then I will be able to safely share those tasks and this content with third parties for further analysis. So for instance, this is what the model identified as sensitive data. So remember, this is still the original document, nothing changed. It's just that the model has identified, okay, this is a patient name, this is a date, a medical record, and so on, okay? Okay, so now if I accept this prediction as an annotator, I go through all of these, I accept another one. Okay, maybe I want to change something. No, everything seems okay. Here as well. Okay, now going back to the tasks. Okay, I see that, okay, I have a couple of submitted tasks, right? Now, if I click pre-annotation again, and now I apply the identification, right? What the model does now is that it looks into the submitted tasks, both entities which were predicted by the model or manually added by the experts, by the annotators, and will apply the identification strategies on top of those tasks. You see that only the ones which are submitted have been changed now, because this is a human in the loop type of workflow, right, where we need some humans to validate that, you know, PHI has not leaked. If something leaked, they will manually change, so that we make sure that, you know, 100% sure that no PHI will be leaked if we are publishing this data or give it away to another team. So usually what happens, what is the process that our customers follow, is that they run the identification at scale on Databricks, then they pick a sample set of documents. Let's say they run the identification on 2 billion records. We had a customer who did that very recently. They picked a sample of those documents, they imported them into GenAI Lab. They had a team of medical doctors, experts in the identification, double check that all the PHI was there, was removed, correctly removed, and then only then they share the data with external third parties. So by the way, they had 99%, our models had 99% accuracy in that use case. It is publicly available, you can check it on our website. Now, okay, so you've seen that now we have, okay, so let me go here. Under the versions, okay, I have the de-identified data. In order to see how the document will look when we export it, you see here the original document with the identified PHI elements of different PHI entities of different types. And here you see the results of the de-identification. You see that the patient name has changed. It was obfuscated, removed, replaced with a synthetic name. date of birth was shifted, and so on, right? Email was replaced with stars, and then you have also, yeah, but the majority of the strategies I chose were obfuscation. So they were actually removed with replaced with fake data, right? So this is what the model will export. If you go to the export page here and you say I want to export with the identification, right? So only those tasks which have been de-identified, which have the status de-identified, will be exported either in JSON format or in text format, and you can share it, safely share it with the outside world. Okay, so let's check the next examples that I have prepared. Okay, so up until now we have seen models which were tuned for text content, right? So they were trained on text and they were applied on text content. Now, one interesting thing with the annotation lab is the fact that it also allows you to import PDF documents. By the way, those are PDF that I generated with the use of some LLMs, so synthetic data, no PHI information or not, nothing like that. But for this particular project, I chose, let me show you in the configuration, I chose to pre-annotate it with models which were trained on text data, right? So now I'm able to import PDF documents into a PDF type of project and run pre-annotation on those documents with text-based model. And this is how the pre-annotations look like. So you see, obviously, this is not a text document, it's a PDF, it's even a scanned PDF. We do recognize, so this one is multi-page, we do recognize all the words which are burned into the image, okay? And then we apply text models on top of the extracted text, right? You see the prediction, the same principle. You can filter those which are low confidence. I can also not show the names of the labels so that it's easier to see the flow. It's very easy to edit this type of document or to add new annotation. For instance, I just click on one of the words. The tool automatically selects the bounding box for that particular word. And I can also select multiple words by just clicking Shift on my keyboard and then select the first and the last token that I want to annotate. And then I select, let's say, I don't know, test. Let's assume that for this chunk, I want to add the label test, right? Then I can update the annotation and submit it when I'm done. You can also create relation between different entities by clicking on the first entity, then pressing the R key on the keyboard and clicking on the second entity. You can also define multi-line annotation, so you can annotate entire sections of the document. You can also, for instance, annotate part of the image if that's something that you want to do by just selecting, okay, let me just, there is this option which will allow users for custom selection of regions. So this can also help me identify maybe parts of an image that I want to annotate with a certain label. Okay, for instance, when I want to annotate, I don't know, cancer entities or tumors and something inside of an image, or signatures or logos or company names and so on. Okay, now you can export this data in different formats, and then you can use it to train models for PDF pre-annotation. Another example I wanted to show is how visual PDF annotation look like. So this is a different use case, which is, so I have here a couple of PDF documents, and here I run pre-annotation using visual NLP models. I have a task to identify the tables and then to extract key and value pairs within those tables, and also annotate logos and signatures. I don't have it here in this task, but probably I'll have it in some other task. So you can check it offline after the training finishes, right? So in this case, because we are using a different template of the project, namely the visual NLP type of project, you will also be able to train a visual NLP model as part of the GenAI lab using the annotations that you have created. With the same structure, you go to the training page and then you train a new model. For this, you will need, I mean, we've noticed that you need a GPU instance so that the training and a VPR instance so that the training does not run into issues, especially if you have many examples of tasks and more complex or more longer documents. Okay, so next, let me show you how to create an LLM evaluation project. Okay, so I'm gonna name the project, pick a name for this project, a short description. Okay, I'm gonna skip the theme creation, and here from the text template, I'm gonna choose LLM evaluation. Okay, we have defined default template for this type of evaluation. So usually you are looking for hallucinations or citation errors or missing citation or memory from memory facts. You can rate the response, or you can use different classifiers to rate the organization, coherence, relevance, helpfulness, or even add comments for the LLM outputs. Okay, so once you have selected this, let's go next. So here you see all the LLM endpoints that I have defined for this. On top of those three, we also support integration with SageMaker endpoints. So if you have a certain endpoint, for instance, if you have subscribed to our LLM models published on SageMaker, or if you have your own LLM model that you want to test using Generative AI Lab, using those prompts run from GenAI Lab, you can define your integration here. Also, if you have data which, for instance, a set of questions or a set of prompts, and then the response is generated by your LLM of choice, which were executed outside of the tool, you can add it as a custom provider here, and then import it and let your team of annotators or of domain experts check the responses and evaluate those. Okay, so now let me, for instance, here, let me just use Claude. And for that, I'm going to ask my admin to give me access to this integration. Okay, so now in my request center, I will see that I have a request to use Claude for the medical LLM evaluation. I'm going to approve it. Okay, so let me refresh this page. Oops. Okay, so now it is approved. I just let this keep this as it is and go to next. Okay, here I can further customize my different evaluation criteria. Let's assume that I have a list of questions. I'm not interested in citations, so I'm gonna just focus on hallucinations. let's say, rate the quality of the response. Okay, then I'll have my response here in the middle, and then I can rate relevance and everything else. Okay, I save this configuration. Okay. Now, if I go to the tasks, what I can do is simply import a list of a CSV file with some prompt examples. I can show you the way this CSV file looks like. It's very simple. Let me first start the pre-annotation. Okay, so currently the tasks just contain the prompt that I just imported, and there is nothing in terms of response from the LLM, right? So now if I start the pre-annotation, okay, so this was not saved. Okay, save configuration. Okay, and now if I I can also select just a couple of tasks, right, and then pre-annotate them. Generate response. Only those 3 tasks will be executed. Now, in the meantime, let me show you how the import file looks like, so that you see it's a very simple file. Okay, it contains 2 columns, the prompt, so the actual question, and the other column is empty, right? Response 1, because I don't want to import a response which was generated outside of the tool. If I would already have the response, I can just put it here, and I don't have to run pre-annotation in GenAI Lab, but I will just my annotators will be able to see the responses generated outside of the tool. Okay, so now, for instance, for task 8, I can see, okay, this is the response which was generated by Claude. I can rate it, let's say, okay, it's a pretty good response, right? It has a, let's say, a strong organization, good coverage, mostly on topic. Well, so anyhow, this is just an example of how the evaluation process works. But what's very important is that the annotators read everything, make sure that information is accurate. For instance, if they spot some hallucination, they can just highlight it, as in the case of other regular projects, right? Then save it and submit it. Okay. So this is the way to evaluate LLMs one by one, right? Let me show you a couple of projects that we have done in-house, for instance, to evaluate grounded responses based on certain documents, right? So here we have some agentic docu project, which will compare responses from 2 different LLMs, for which we have uploaded the PDF, some PDF files, and then ask them this question, right, and ensured that the response, or make sure that the response should come from the uploaded document. So you can notice here that for the response in the left side, we have some, so this is HTML content, it's no longer text content, as in the case of the LLM evaluation project that I showed earlier. So here we have HTML code. If I click on this one, for instance, I see a pop-up with a section of the document which is cited here, right? And I can navigate to double check that the responses are well grounded and the references are correct, right? And here I have the response from another type of LLM, which just does not provide the actual section from the document which was used, but just tells you the page. You see PDF 16 at page 4, I think row 9. So the annotation works the same. One other thing, what we have done for this project, for instance, we have tried to set up some ground truth data so that we have automatic evaluations. So we have a benchmarking data set, and then in the future, once we change the agents and the models behind the scene, we still have some benchmarking data that we can use to automatically check that the responses have increased in quality instead of decreased. So here you can select, which one of the responses you prefer, whether or not this can be selected or considered as ground truth. And you can see that some of the annotators that consider that the response is not sufficiently good, they have entered a ground truth response, probably by selecting one of the responses which was better and then editing it so that it covers the entire picture and it has a higher level of details. Okay, so let's see another example. So usually, sometimes you need to know what you are evaluating. Like in this case, it was pretty clear that okay, here the annotators knew what they were evaluating, what is model 1, what is model 2. But sometimes you want to run also because the structure of the responses were very, very different and they were familiar with those two models and the way they respond. Sometimes you want to run blind evaluations, and we also added support for that use case. And here, for this type of blind evaluation, what happens is that, let me show you, I have selected 3 different LLMs. So here you can add whatever LLM endpoints you have, for instance, on SageMaker, or upload, as in the previous examples, responses already generated outside of the tool. But what's different here for this template is the fact that when the any users click on a task, the responses are randomized, and they will not be able to tell which response comes from which model, right? So they are randomized on the screen, and they don't have access, but this is true in general, they don't have access to to see which model generated which response, right? So they go ahead, they read the text, they evaluate using the different criteria that apply to this, to this use case, and then at the end you can check. You have a different, a specific type of analytics for LLM response comparison projects, where you see, okay, which is the model which won which was considered as better in most of the cases, and you can check for occurrence of hallucinations. You see here that there was one occurrence where one response where those 3 models hallucinated. Majority of the responses there was no hallucination, right? No citation errors, because this does not apply for this current project. And also in terms of organization and coherence, you see that score, for instance, Claude scored 4 out of 5 in 7 documents and 5 in 2. And then you have a high-level overview of the quality of those 3 LLM endpoints for the specific task according to all of those criteria, right? In terms of coverage and amount of information, relevance, helpfulness, and so on. Okay. One other thing that I do want to show you very briefly, because I think I forgot to mention it during the previous demos. Okay, so for all of those projects, for the labels and for the labels added into your taxonomy, you can specify annotation guidelines, and those are very very important. For instance, during the let me just edit one so that my annotation guidelines will appear. So during the annotation project, you'll always have the definition of the label that you are working with, the labels you are working with, and the labels, I mean the definitions defined by consensus by the annotation team right at hand, right? So you can activate this and you see, okay, those are some examples on how to annotate adenopathy. It can have some assertion labels on top of it, and it can be included into this type of relation, right? And you can move between the different entities. All of those which have annotation guidelines have a small dot here on the right upper side of the label box, right? So yeah, so this improves a lot the annotation speed and the annotation process, also the consensus between the annotators, because they always have this information at hand. They can edit it and update it as part of the consensus meetings. And this applies to LLM comparison, to different NER types of integration and projects. They can be applied to prompts and rules and so on. So we made sure that all of the rules established as part of, by the team are always available and used for creating high-level annotations. Okay. All the features that I have shown you using the UI can also be accessed via the API. So under the settings, you have the API integration page, which presents all the API endpoints which are available. So you can create a project, update it, list all projects, clone the project, import, out, export, configure projects, and so on. So I have here a brief example of how you can integrate GenAI lab within your usual regular workflows, right? So I'm going to just run this. I can share this notebook with you for to check later on, so that you see some examples. Let me just run on SAS. Okay, you see some examples of on how you can create a new project via Python code, how you can connect to the GenAI lab instance, import data, export data, and so on. So what you need to have at your hand is the username and the password that you use to connect to this instance. And also on this API integration page at the top, you have the client ID and the secret key. This is specific to the instance. So once you provide username, password, annotation, client ID and secret ID, you can connect to the instance and then interact in order to create projects, import tasks, run pre-annotation, and so on. So this notebook, for instance, should have generated 2 new projects. Yeah, you see here one comparison project with a couple of tasks. Oh, but now I'm annotator. If I switch to manager, I see the tasks which were created, and they were already populated outside of the tool. So I just via this Python notebook, I just imported 3 different responses from the 3 different LLM models for the same prompt. And I have the second project is the identification project. Here, some synthetic PHI tasks were imported, and they were already pre-annotated using the cluster which is deployed here, because clinical de-identification pipeline is the same across projects. So because this cluster was active on my instance, I was able to use it to pre-annotate the tasks imported as part of the project using this particular cluster. So I have shown you this page a couple of times. Maybe it's worth telling a little bit more about it. So this is another way to abstract the complexity around model deployment and around using pre-annotation and training. for domain experts. So people who are not programmers, who are not developers, who don't actually know how to run a Python notebook, right? So the idea that we had when we created this generative AI lab tool was to empower our own team of medical doctors to be able to be independent, to be able to create their own projects, to annotate their own data, to train their own models, to tune models for specific use cases, and so on, by abstracting all the complexity behind model deployment, model training, and so on. So under the cluster page, you see all the models which are deployed on this server where the instance of Generative AI Lab is hosted. So if you install it on your own environment, all of those pre-annotation clusters will be deployed locally, so they will not call home. The only time when you interact with the outside world is when you use LLM-based prompts. Then you send data to maybe ChatGPT or Claude, or maybe you have a private instance and you are safe in that situation. But anyhow, you have to make sure that when you integrate with external LLM providers, you don't send sensitive data for pre-annotation purposes or for summarization or other tasks. But all of those clusters that you see here, which are deployed as part of project configuration deployment, they run locally on your machine and they don't call home. Right? So they don't send data or tasks, content outside of the instance. All the processing is done locally on this environment. Under system settings, you can see that we have some information about infrastructure, and you see the resources which are used for the training server and for the pre-annotation server. You can edit those as you see fit according to the size of the machine where you do the deployment. So here, for instance, I have a 32 CPU machine, so I can run more active servers in parallel, and I can, maybe assign more resources for training and for pre-annotation just to make them faster. You can, of course, back up all the data, all the projects, the users, and then restore restore from those backups. You can define your integrations here with LLM service providers. And here under the licenses page, you can import your license key, either by drag and dropping your license JSON file, or by integrating with My Johnson Labs if you have your license available on your account on Johnson Labs. Okay, so one other important feature that is supported by the Generative AI Lab is the audit log. We only have around 10 minutes, so let me just quickly show you. So when you install Generative AI Lab, if you want to activate audit logs, you are able to do so by adding two very short lines. Let me just show you in this presentation. So you have all of those details about the different audit dashboards that are supported out of the box by Generative AI Lab inside of the PowerPoint presentation that I will share with you. You can check what each one of those audit dashboards can be used for, what's the purpose, how you can keep track of your users' activity, of the exports and imports of pre-annotations, and all the actions which are performed on the projects defined in your instance, on the data. And this is on top of the completion trails that you already see as part of the UI. Okay, so this will show you precise all the actions which are have been performed by each of the users and the date when they were performed, and you can set up different additional dashboards to help you monitor API requests, the status of the API and of the instance, the user's activities, usage of the instance per hour. So you'll see, which are the peak hours, and you can maybe schedule more complex or higher batch activities in periods of low activity time. So in general, in healthcare industry, it's very important, and it's actually required by the law to implement audit controls that record and examine activity within your system, especially if you are handling electronic or protected health information. So you have to, specifically HIPAA mandates tracking of access to patient records, changes done on the PHI records, logins, logouts, failed login attempts, data exports and transmissions, administrative changes, and so on. There is also a requirement that the audit logs must be protected from tampering, retained for at least 6 years in many cases, and must be available for audit and investigations. And Generative AI Lab provides all of that. So as I said, you have different dashboards here. You can see the project activities, let's say in the last 4 months. So you can select here the project that you want to check. Let's see, maybe, okay, this one. And what were all the actions which were performed by all the users on this particular project and the time of that action. You can see, check the user behavior as well. Okay, who are the most active users, the user per hour and day, right? So when is the system most loaded, and what are the projects which are most have a higher activity, which are probably the active projects. Also, you can see detailed information about, let me just refresh this. Okay, projects, when they were created, who created them, who deleted certain projects, who exported them, who exported the tasks, and in case you want to restrict the exports, for instance, it's also possible to restrict that from within the system settings of the Generative AI Lab, so nobody will be able to copy or move data from your let's say sensitive project outside or on their local environment. Okay, what else? And you can also see what were the interactions that were made via API in the selected period. You see the high peaks when there was more higher activity rate. Also the status code for the HTTP request, and then the projects or the calls which were problematic and which ended with some errors, or which were successfully executed. Okay, so finally, as I said before, you will have access to all of the slides and to the sample projects that I have shown today on GitHub, and they will be shared with you via email. Before I wrap up, I wanted to share some additional resources that will help you interact or get access, get more permanent access to Generative AI Lab after today's session and after the 2 weeks that you have for as part of your training privilege. So you can subscribe. The application is available on AWS Marketplace or Azure Marketplace, and you can subscribe to it and deploy the application on your private VPN, or you can also get in touch with our sales team for an on-premise deployment. We are usually offering training session for on-premise deployments and support for running the actual installation in case that is necessary. If you have any questions or run into issues, you can contact us via Slack. We have a dedicated channel on Slack, and you can also reach out via email at support@johnsonlabs.com. So here you see additional resources, the landing page for Generative AI Lab on johnsonlabs.com website. We have here the documentation web page. Also, we have published a couple of tutorials, step-by-step tutorials for different types of projects. And we also update or publish regularly blog posts covering new features of the Generative AI Lab application, or release notes, or comparison with other tools or information about new use cases that we have added and that we support. So that brings us to the end of today's session. Thank you very much for joining. I hope this session helped you better understand how human-in-the-loop AI can actually accelerate your AI projects while maintaining transparency and compliance and ensuring a high quality level for your annotations and for your data curation projects. If you have any questions after this session, please don't hesitate to reach out. You can contact me at johnsonlabs.com or reach out to our support team. So once again, thank you for spending your time with us today, and we look forward to seeing what you've built with Generative AI Lab. Thank you.
Thank you, Dia, and thank you everybody who joined us today. You will receive the recording of this session in a few hours once it's processed, and we will see you again hopefully tomorrow at 9 a.m. Pacific or noon Eastern, and we will continue the Applied Generative AI session tomorrow. Thank you again. Please reach out to us if you have any questions, and we'll see you again tomorrow.